Hello dear students, welcome to IMS Academy. So my dear student, we are live here for the complete mechanical analysis GATE 2023 exam, which was conducted just before 30 minutes, 2:30 to 5:30 afternoon session. How many of you guys ready for the questions? Okay, just let me know in the chat box. If any of your friend who is planning to write the GATE exam in the upcoming Saturday, Sunday, upcoming Sunday, that is on, that is for EE and EC. Mechanical and aptitude questions are very much important for those students who are supposed to write for EC and EE paper. So dear student, first of all, we will have a discussion on, first of all, let me know, am I audible? First of all, just confirm audio and video, Pragya. Yes, very good, very good. Okay guys, so first of all, I have a complete type of questions representation here guys, the total number of MCQ, NAT and MSQ. So out of 65 questions, the total number of MCQ where we have a negative marking, the number of questions are 30 MCQ. Numerically answered question is 27, where we don't have a negative marking, but at the same time we don't have options to eliminate. Yes or no? Guys, just confirm audio and video, bachcho. Just confirm audio and video. Yes, confirm. Okay, very good, very good. So first of all, who has appeared for the mechanical exam? You can also share your experience. According to our mentors has also appeared for the GATE exam. So according to their experience, the exam is moderate to tough. Exam is not easy to moderate. Exam level is moderate to tough. Okay, guys. Now, the total number of MSQs, multiple select questions, are 8. So here the advantage, MSQ or NAT, we don't have any negative marking. So if you will add 27 and 8, it will be 35. So out of 65 question, in 35 question, we don't have negative marking, guys. That must attempt type of question. But here is the 30 question that where you need to take care, because here we have a negative marking. So I hope, so first of all guys, just share this link of this YouTube video so that other student will also get the information that IMS GATE Academy live here, and we are solving live detailed solution of mechanical GATE 2023 exam, just like computer science we have completed. So dear student, okay, so now I have a question. I am from electronics stream, but I am solving one question here that is from Laplace transform, and those who are from EC electrical, you all guys have a exam tomorrow morning 9:30 for EE and evening afternoon session 2:30 for EC students. So when you will see that question now, you can easily solve. If you have attended my classes ever in the past, you can easily solve that question within 20 to 30 seconds. The question comes from Laplace transform. I am going to take that question, but first of all, just do reply. How many of you guys in the chat box appeared for today's mechanical exam? Have you appeared for the mechanical exam? What was your experience? Tell me, what was your experience about the GATE? As far as or whatever the response we are getting till now, according to that, the exam paper was moderate to tough. It is not at all easy to moderate. It is moderate to tough. So we are expecting that cutoff will be not so much high, because the difficulty level is high. And here we can say that, just if I talk about the computer science paper, today's forenoon session, that was easy to moderate. But this mechanical paper, whatever the inputs and whatever the inputs we are getting from different aspirants till now, according to that, question is tough. So I am expecting more than 50 students will be in the live. Guys, do share it so that I can start the first question here. I'm going to start the first question here in a live. The question is, the detailed question is here, guys. I'm writing the question here. All of you just, meanwhile, other students should also share. We have a Telegram channel given the description. If you have any question, you can directly send in the Telegram group, guys. You guys can directly share in Telegram group. Do it fast. Do it fast, guys. Okay, meanwhile, I am writing the question. Meanwhile, I am writing a complete question for you, okay? Just wait, just wait. The question is, this question is MCQ. This question is MCQ and this question is 2 marks. I am telling you, my dear student, it is a gifted question. It is not deserving 2 marks. It is a gifted question. Yes, sir. I'm a big fan, sir. Okay, AJ, thank you so much, beta, for your lovely words. But share it to maximum so other mechanical students will also connect with us. The question is, which of the option given, which of the option given is the inverse Laplace transform, 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 is the inverse Laplace transform of, is the inverse Laplace transform of 1 upon s cube minus s question mark, where ut is given as a unit step signal. However, maybe this question is not so much easy for mechanical students, but if I talk about EC electrical iron, those are having signals and system subject in the syllabus. For those, this question is very easy. Of course, this Laplace transform is not in the syllabus for EC electrical iron as far as mathematics syllabus is concerned, but for mechanical students in the mathematics syllabus, Laplace transform is there. It is easiest question, guys. If you know the simple partial fraction, you can easily solve this question. It doesn't deserve. This question is not deserving 2 marks, I am telling you, but it is a gifted question for you all. So I am solving this question here. All of you just let me know how many of you guys have seen this question in the examination hall. How many of you guys seen this question? Tell me. So you can write like this, guys. 1 upon s, you can take common, so inside the bracket you will get s square minus 1. And after that, what you can write? Do you know a plus b, a minus b, guys? A plus b, a minus b, a square minus b square. Yes or no? How was the aptitude? Aptitude and maths, Priyanka ma'am is about to come just after me. Just wait for the next 5 minutes. This is the question of engineering maths only. This is the question from engineering maths only, guys. I am solving engineering maths question here, but the remaining engineering maths and aptitude question going to be solved by Priyanka ma'am just after 5 minutes. But before that, you have to share it maximum. Manik, good evening, Manik. So tell me, my dear student, s square minus 1. A plus b, a minus b, very easy, sir. It is s into s plus 1 into s minus 1, sir. No problem at all. Yeah. Now I am going to take a next slide here, and I am writing the same expression because we have enough space here. So s into s plus 1 into s minus 1. Now have you heard the name of partial fraction, guys? Just do it and take the inverse Laplace. That's it. So if I will take the partial fraction, first s plus, then s plus 1, then s minus 1. And I have given amazing short trick for the same. I have given the short trick for the same. If you are looking for this coefficient a, then first of all you need to hide this part s. So s equal to 0. You need to equate this term equal to 0. So you will get the s value 0. Now you need to hide the part of s. Now after that, wherever is s, you need to put s equal to 0. So here and here, when you will put s equal to 0 now, you will get minus 1 only. So it means directly a value you can calculate. That was a traditional method, that A, B, C, that is a redundant method. My student will not solve. You can solve like this. S plus 1. When you will put s plus 1 equal to 0, when you will put s plus 1 equal to 0, you will get s equal to minus 1. Now this time you need to hide this s plus 1 part, and now wherever you will see s, you need to put minus 1. So here is minus 1, so minus 2 and minus 1, so it will become plus half. So it will become plus half. Yeah. Now s minus 1 equal to 0. You need to equate this s minus 1 term equal to 0. S minus 1 term equal to 0. So you will get s equal to s minus 1 equal to 0. So s equal to 1. S equal to 1. Now you need to hide this part. Now you need to hide this part, and wherever you are seeing s, you need to put 1. So 1 plus 1, 2 and dot 1. So it will be again 1 by 2. Now, do you know the inverse Laplace concept, guys? The inverse Laplace concept says that, sir, 1 upon s plus a, 1 upon s plus a, inverse Laplace transform, ILT, inverse Laplace transform will be always e to the power minus at u of t. If we talk about 1 upon s minus a, the inverse Laplace transform, ILT, will be e to the power plus at u of t. So this is the basic foundation concept of Laplace transform. It is a gifted question, as I told you. Now here you will get minus 1 upon s. Do you know the Laplace transform of inverse Laplace transform of 1 by s, ILT, is nothing but ut only. So minus sign is as it is. Here you can write ut. Here also you can write plus half e to the power minus t into ut and plus half e to the power plus t into u of t. Here you can take ut common also. So you will get the answer minus 1 plus half e to the power minus t plus half e to the power plus t and whole bracket close, you will get ut. And do you know how many options are given? There 4 options are given. And what are the options? I will show the options as well. I will show you the options as well. Okay. So the options are, option number A is here. Option number that is given in the question, that is 1 by 3 e to the power minus t minus e to the power t whole bracket close ut. This is the first option. Option number B. Option number B will be minus 1 plus 1 by 2 e to the power minus t plus half e to the power t dot ut. Option number C. So if the given data is this, now I think you already got the answer. Option number C is minus 1 plus half e to the power minus whole bracket t minus 1 plus half e to the power whole bracket t minus 1 and whole bracket ut minus 1. Yeah, ut minus 1. Similarly, option number D also given, and D was minus 1 minus half e to the power minus t minus 1 e to the power minus t minus 1 minus half e to the power t minus 1 whole bracket u of t minus 1. So now you will see that, guys, option number B for Bombay is only correct. Option number B for Bombay is only correct according to your answer. Monak Roy, tell me yes or no, guys. So 48% students are saying that question paper was tough. 44% students are saying question moderate, and very 6% students are. So as I told you initially, the question paper of mechanical 2023 was not easy at all. It is moderate to tough. The level is moderate to tough, because many of our mentor also appeared for the GATE 23 exam and they also feel the same. They also told me just before 10 minutes, sir, the question paper was not at all easy. For the student point of view, it is definitely moderate to tough level. If you prepared well, then only your paper was a good attempt. Otherwise, maybe you you are feeling that you are not able to convert a good marks, and you are not able to uh, generate a good marks in this GATE 23 examination. Yes or no? So don't worry about that, because if the question paper is tough, it is tough for all of you guys, all the students. It is tough for all the GATE aspirants. Okay. So accordingly, cutoff will vary. Okay. Don't worry about that. So now I am waiting for the next, just to make live learners the current. I can say that 38 students are in live. Just make it 50 plus, guys. Just make it 50 plus, so that I can invite the next faculty member. So guys, just let me know, am I audible or not, guys? Just let me know audible or not. First of all, tell me how many of you has appeared for the GATE 23 mechanical paper from the chat box. Tell me, student, how many of you from the chat box has written the GATE exam? Do reply fast. You have seen this question or not? You have seen this GATE question or not? It is a mathematics question and it was a MCQ 2 marks question. How many of you attempted this question? Tell me. How many of you attempted this question, guys? Do reply. Do reply fast. Do reply fast. Just do reply in chat box, guys. Do reply in chat box. And many more questions about to come. Engineering mathematics, general aptitude, your mechanical question, thermodynamics, your FM questions, SOM questions, okay, your machine design questions, all the subject, industrial question, heat transfer question will come one by one, okay. So now the next voice from Priyanka ma'am, and she will going to solve the engineering mathematics and aptitude questions from mechanical GATE 2023 exam, okay guys.
Hello everyone, welcome to IMS Gate Academy. Hello everyone, welcome to IMS Gate Academy. Hello. Yes, I hope now my voice is also clear. So dear students, here I am ready with the few questions of engineering mathematics and aptitude also. So let's start with the question of, first of all, let's start with the question of engineering mathematics. Acha guys, tell me, how was your paper? How was your paper? If you guys gives the review, then it will helpful. So how was your paper? Okay, so let's start with the very first question. This is a numerical answer type question and the weightage of the question was 2 marks. The question is from differential equation. As I used to say, dear student, that differential equation is a topic which is easily scorable. So if you learn the basics in differential equation, okay, I hope surely you guys approach the question. And yes, this question is from Cauchy's equation, means the differential equation with variable coefficient. Let's approach the question. So the question is, this was an NAT and the weightage of the question was 2 marks. Okay, the differential equation x square d2y by dx2 plus x dy by dx minus y equals to 0, x is greater than equals to 1. Okay, initial conditions are given to us. Few initial conditions are given to us, that y at x is equals to 1 is 6 and the derivative dy by dx at x is equals to 1 is 2. We need to find out the value of y at x is equals to 2. So let's approach the question. We need to find out the value of y, means value of the function at x is equals to 2. So yes, okay, so let's see, let's approach the question. As we know very well, this is the differential equation and differential equation with variable coefficient. So first of all, as we know, in these type of questions we have to put something at the place of x d by dx, okay, x square d2y by dx2, and we used to start from the answer is 2. Oh, not my, I don't think it is true. Let's approach it. So we are having the equation. So first of all, I will put here in the equation x is equals to e power z, or z is equals to log x. Okay. And I will go with the x d by dx. We can put it equals to q. Okay. Anything you can put. We can go with x square d2 by dx2 equals to q minus 1. Okay, you can as I used to say, some used to, yeah, it is 9. Very good, it is 9. So someone used to put it as d, you can put it capital D, you can put it theta, you can put it q, anything you want you can put. So if I will just convert this one, then my equation, this will become q minus 1 plus x d by dx, that is q, we are having minus 1, and y equals to 0. From here I can find out the auxiliary equation by solving this one. Q square minus q plus q minus 1 equals to 0. These two things will be gone. If I will write down the auxiliary equation in the form of m, it will be m is equals to plus minus 1. Okay, I'm having m square is equals to 1, then m is equals to plus minus 1. So I can easily say that the roots of the equation are real and distinct, or different. If the roots are real and distinct, then this is a Euler's, this is a Cauchy equation or differential equation with variable coefficient. So the CF, YCF will be C1 e to the power z, and next is minus, so C2 e to the power minus z. We can write down the equation in the form of x, so it will be as told you already, we have to put x is equals to e power z, or z is equals to log x. So I will put, when I will put e power z is equals to x, so it will be, it will be c1 into x plus c2 x power minus 1. So more and more you can write down YCF is equals to c1x plus c2 by x. So this is the y. But here in this question now we want dy by dx also, because the initial conditions are also given for dy by dx. So we have to write down the dy by dx also. So that's why I'm finding dy by dx itself here only. So dy by dx will be c1x and c2x minus means 1 by x. So it will be minus c2 by x square. Okay. Now we can use the boundary conditions which are given to us. At x is equals to 1, y is equals to 6. At x is equals to 1, dy by dx is equals to 2. So we can use both the condition, dear students. So when we will use it, so from here I can write down at x is equals to 1, y is equals to 6. So at x is equals to 1, y is equals to 6. If I will put here, it will be c1 plus c2 is equals to 6. I am having equation number 1 for which c1 plus c2 equals to 6. Now let's put here also dy by dx is equals to 2 when x is equals to 1. So when I will put here dy by dx is equals to 2, x is equals to 1. So it will give me c1 minus c2 equals to 2. If I will solve these two equations, I can get the values of the constants c1 and c2 beta. So when I will solve, so I can write down c1 plus c2 equals to 6, c1 minus c2 equals to 2. When we will solve, we can get 2c1 equals to 8. Hence the c1 is equals to 4. If I will put the value of c1 here, it will give me the value of c2 also. So it will be 4 plus c2 equals to 6. Hence my c2 will be 2. I am having c1 and c2. Now I can put the values in the solution, which was c1x plus c2 by x. So if I will put the values, it will be 4x plus 4x plus 2 by x. I need to find out the value of the function at x is equals to 2. So when we will put here x is equals to 2, it will be 4 2 ja 8 plus 2 by 2. So it will give me 8 plus 1 9. So the final answer will be, dear students, 9. As this is a numerical answer type question, so we have to type here we have to write down the answer, which is 9. So this will be my final answer, and the question's weightage is 2 mark. We know that the question from differential equation is very easy and scoreable. I'm damn sure if you approach this question, you did it very well. Clear to everyone? Yeah, very good, guys. So please confirm you approach the question now, and it is very simple. I'm having one more question of One more question of engineering mathematics. Okay, let's approach. That question is from complex variable, and that is also a NAT. Okay, numerical answer type question. The weightage of the question was 1 mark. The simple basic question which we were expecting in the complex. As I used to say, bacha log, okay, in the complex variable we can expect only two pattern of questions. Okay, maximum. First is the question based on the analytical function, and second is the complex integration. So here we are having the question from the analytical function. So let's approach the question. The question is, it is given to us, given analytic complex valued function, given analytic complex valued function fz equals to e to the power minus kx cos of 2y minus iota sine of 2y. Okay, where z is the complex function, x plus iota y, we need to find out the value of the unknown k. So we need to find out the value of k. Let's approach it. As we know very well, whenever a function is a complex, okay, whenever a complex function is said to be analytic, it means that function must satisfy the Cauchy-Riemann equation. So here we can use the Cauchy-Riemann equation. Okay, for using the Cauchy-Riemann equation, first of all we have to identify from here the real function, means the real part of the given function, and the imaginary part of the given function. So from here we can write down the real part, means u, which is nothing but e to the power minus kx cos of 2y, and the imaginary part v, which is nothing but minus e power minus kx sine of 2y. We are having both the functions. Okay, we can approach in any way. If okay, what is the Cauchy-Riemann equation? According to the Cauchy-Riemann equation, ux is equals to vy and uy equals to minus vx. So if we approach the partial differentiation of u with respect to x, and if the function is an analytical function, then it must satisfy the Cauchy-Riemann equation. In this case, we have to put ux is equals to vy. So by, yeah, very good. No, it is 2. Who's that? Abhinav. Yeah, shabash. It is 2. Very good, Abhinav. Okay, Abhinav is our regular student. So very good. It is 2. So let's approach it. We can approach here del u by del x. Del u by del x is nothing but minus e to the minus k e to the power minus kx cos of 2y. And from here we can find out the del v by del y, because I have to put ux equals to vy. So ux is u, partial differentiation of u with respect to x, partial differentiation of v with respect to y. So when I will find out from here y, so it will be minus 2 e to the power minus kx, differentiation of sine will be cos of 2y into 2. Okay, so we can compare these two things. By comparison we can check, by comparison we can write down, just 1 minute. Okay, so by comparison we can write down from here that ux is equals to vy, and it will give me minus k e to the power minus x cos of 2y equals to minus 2 e to the power minus kx cos of 2y. We can simply okay, it is minus k we are having. We can simply approach the question by the comparison. We can see minus and minus is gone, so clearly k is nothing but 2. So we can compare that k is equals to 2, and we can approach the question very easily, isn't it, guys? So that's why we can solve the question very easily in a very simple manner. Okay, यूनिट स्टेप फंक्शन का क्वेश्चन भूल गया, इनवर्स लाप्लास का इजी क्वेश्चन आया था, कॉन्सेप्ट ही भूल गया। आहा, चलिए कोई दिक्कत नहीं, बहुत आसान सा क्वेश्चन आया था, अभी जस्ट अंकुर सर ने सॉल्व ही करवाया है वो क्वेश्चन। नाउ आई एम हैविंग वन क्वेश्चन ऑफ wait a minute, I'm having one question of general aptitude also, so let me write down that question. So that question is from DI, so let's write down the question. The question is, a certain country a certain country has 504 universities, okay, universities and 25951 colleges. So these are categorized into three grades. Okay, categorized into grade 1, 2 and 3. Grades 1, 2 and 3. So what is the percentage? What is the percentage correct up to 1 decimal places? Okay, this is again a NAT question, dear students. So correct or not? Is it NAT? No, this is an MCQ. We are having options also. So correct up to 1 decimal that fall into grade 3. That fall into grade 3. Okay, we are having two pie charts also. So please guys share the link of this session with each and every student, okay, who are going to appear in the exam. Tomorrow you are having exam or in the next weekend. It will be helpful for you so that you can just find out the pattern of question. You can see, okay, the level of question, level of paper, and yeah, you can analyze yourself also. So please share it with maximum. So we are having two diagrams here, two circles. For this one we are having 1, 2 and 3. So this is this one is grade 2, this one is grade 1, this one is grade 3. The percentage is 7%, this is 62% and this is 31%. This one is for universities. Okay, we are having for one more circle for the colleges. Yeah, in colleges also we are having three categories, 1, 2 and 3. So we can see this one is grade 2, percentage is 68% and this one is, okay, this one is grade 1, 9%, this one is grade 3, 23%. Okay, let's approach it. So it is asking about the grade 3 overall. Yeah, it is very good, Moyank, shabash. Yeah, very good, Abhinav. 22.7 is absolutely right answer, Abhinav and Mayank. So we can see from here it is asking about the grade 3. So we have to identify both the things for grade 3. We have to identify the college and universities both. So how we will approach? Let's write down here. As we can see, the universities are 504 and the colleges are how many in the data? It is 25951. Okay, right? So we can see it is asking about grade 3. So look at here, the grade 3 in universities, that is 7% of the total universities, and grade 3 in colleges, that is 23% of the total number of colleges. So we can approach like this only. So we can write down the 7% of, or the required number, okay, required number of percentage, है ना? That is equals to 7% of the universities. How many universities? 504. So 7% of 504 plus 23% of the number, total number of colleges, 25951, divided by the total number of institution including college and universities. So beta, it will be 25951 plus 504. So this will be the total. So when we will solve it, by solving this one, we can get the result as 22.69. But in the options we are having, okay, I just did not write down the options. Let's check the options also so that you can clearly get the notification. 6.8%, 23.7%, 22.7%, and last one is 15.0%. So we can see from here it is 22.69%, but the question is asking about, okay, around the 1 decimal places. So we can round off it one and we can write down the result as in 22.7%. So my answer will be this option, which includes 22.7%, dear students. I hope this is clear to everyone. Yes, very good. Shabash. So these are the questions right now I'm having. Okay, I'm focusing on more questions. I'm approaching more questions or finding more questions of general aptitude and engineering mathematics for you, dear students. So just stay tuned to our channel. We are going to have the detailed discussion of each and every question which is available for us. Okay guys, right? So right now I'm holding and I'm just giving the next to the technical teams or technical questions. Okay, hold on, I will come again and we will have a discussion on more questions of maths and aptitude here only. Okay guys, thank you.
Hello students, welcome to IMS Gate Academy. We have two questions from the SOM. Now I am going to discuss about a cantilever beam which is fixed at one end and it is supported by a load at the free end. So my dear students, it is a very simple question. I hope all the IMS students have answered this question. So here we have a question with the flexural rigidity of value EI and a load W is applied at the free end. So my dear students, as you know, here the length of the beam is considered as L. The length of the beam is considered as L. So here what is the question they have asked is, what is the value of the stiffness? What is the value of the stiffness? So here they have asked the value of K. So it is a very easy problem, my dear students. So you will find the stiffness value is nothing but load upon deformation. Load upon deflection. Okay, it is nothing but stiffness is nothing but load upon deflection. Here we have a point load that is equal to W. My dear students, the deflection for a cantilever beam, you have to remember this. The deflection for a cantilever beam with a load subjected to point load at a free end, the value for deflection is given by the formula WL cube upon 3EI. So here, my dear students, if you have faced any issue with delta, we also have how to find out the delta value by using this formula, that is AX bar upon EI, where A represents the area of the bending moment and X is the CG location and EI is the flexural rigidity. For a cantilever beam, the bending moment varies in the form of triangular shape. So if you calculate from this equation also, you can remember that deflection is equal to WL cube by 3I. Now just substitute in the stiffness. You know stiffness is equal to load upon deformation. That here the deflection is nothing but WL cube upon 3I. So my dear students, here if I cancel W and W, the stiffness value can be written as 3EI upon L cube. The option here is 3A upon L cube. I hope you are clear. So the options given here are option A. Option A is 2EI upon L cube. Option B, we have 3EI upon L cube. And option C, we have L cube by 3EI. And option D, we have L cube upon 2EI. So let me tell you what is the answer, students. Quickly respond. You can share this session, my dear students. Today we are going to solve all the problems of mechanical engineering. And so what is the option here? We have got the answer as 3EI by L cube. Everyone has written this answer correctly. So the option B is correct. I hope you are clear, students. Now, my dear students, another simple question in strength of materials is, they want to identify what is the plane stress from the Mohr circle diagram. So they have given you the options, my dear students. The options here are option A. We have the Mohr circle, and option B, we have the Mohr circle, And option C, we have the more circle in this way. Okay. 1 second, student. And option D is, we have the more circle here. 1 second, students. Here, option C is given as one second. So here we have the option C. So here, my dear students, they have asked you what is plane stress from the following diagrams. So what is plane stress from this diagram? Simple funda, my dear students. We have a simple funda that the more circle center should always lie on the x-axis. So here it is a multiple select question, students. So we have the center at here, and we have the center here, and we have the center here, and we have the center here. So the option A is correct because we have the center here, and the option B is wrong, and because the center is at not on the x-axis. Here the option is the center is on x-axis, so the option C is correct, and the option D is wrong because the center is not in x-axis. I hope these two problems related to strength of materials, everyone has done this, and please share this session, and you will be able to, we are able to answer all the questions of mechanical. So stay tuned, students.
Hello students, welcome to IMS Academy. So here I'm come up with a manufacturing question, okay, which is from metal cutting. Okay guys, now let us have a look on data. They gave that they asking you to calculate, they gave in the problem cutting velocity and rake angle, shear plane angle, and also average thickness of the deformation zone also given. Now they are asking you to calculate that shear strain rate will be. Okay, now let me write given data. So cutting velocity, VC we call, that is given 1 meter per second. Yes guys. Next rake angle alpha is equal to, it is given 5 degrees, and shear plane angle that we call it as phi, that is given 45 degrees. Okay, now average thickness of deformation zone, that is equal to, given it is 25 into 10 to the power of minus 6 meters is given. Okay, now they are asking that shear strain rate. Okay, this is what the given data. Now what we have to calculate? Shear strain rate. Now let me explain you how to do that. This problem we have already solved in our regular classes. Shear strain rate, right? Shear strain rate we have to calculate. This is what the given data, guys. Okay, right. Now as we know that shear strain rate is equal to shear strain rate is equal to, it is, you know, shear velocity during machining is divided by, you know, deformation zone thickness or shear plane thickness. Shear plane thickness. Alright guys, now as if I write this fellow, and Vs is divided by Ts, shear plane thickness, I say Ts, that is what here given. So this is, we can also call it as Ts guys. Okay, right. Now my question is here, we don't know that shear velocity, we don't know that shear velocity, we know that shear plane thickness, but how to find this shear plane velocity? So they gave that one relation, that cutting velocity they mentioned. So from the cutting velocity you need to derive your shear plane velocity, right? For that I gave you that shear plane, see, so velocity triangle, velocity triangle, velocity triangle. From the velocity triangle we know that, from the velocity triangle we know that, you know, so this is, no, not require this. Right. So this angle is phi, and this is our cutting velocity Vc, and this is your 90 minus alpha. This we have derived already guys, right? 90 minus phi minus alpha, and this is Vf, shear chip flow velocity, and this is your shear velocity Vs. Okay, now apply sine rule here. So if I apply sine rule here, now here Vs is divided by opposite angle, it's sine, so that is sine 90 minus alpha, that is equal to, and Vc is divided by, so sine of 90 minus phi minus alpha. Okay, now if I simplify this equation, so that I am going to get, it is Vs by cos alpha is equal to, it is Vc by cos of phi minus alpha. So do you remember this guys? Do you remember this? Yeah. So from there we need to find Vs. Okay, now I'll write my equation, that is Vs is equal to, it is Vc into cos alpha is divided by, so cos of phi minus alpha. So from there I am going to get, it is a 1, right? So and cos, 1 minute, and then cos, you know, alpha ni 5 degrees, and cos of shear plane angle is 45 degrees, and it is 5 degrees. Okay, now if you solve this, then you are going to get 1.30045, so meter per second. Okay, so because velocity is given meter per second, right? Now we got Vs, and we know that Ts also. Now substitute here shear strain rate. Shear strain rate we indicate with this one. So shear strain rate is equal to, I'll write it as, so 1 point only. Yeah, 1.30045 is divided by, you know, it is gonna be a 25 into 10 to the power of minus 6. Yes guys, this is for meter per second, and here at the down here we got meters. Now if I solve this, my shear strain rate is equal to, I am going to get, it is 25 into 10 to the power of 4 second inverse. Okay, because meter will get cancelled, 1 by second means second inverse will come. This is what your shear strain rate. Guys, I told you that one more thing, if you remember or not. So if you are able to remember this, shear strain plane thickness, if it is not given in the problem, in that case I told you one statement, that shear plane thickness is equal to 1 by 10th of its shear plane length. Okay, so if you remember that, so that even if it is not given, if you from the shear plane length formula we can find this and substitute here. Okay, but fortunately the problem is given here, shear plane thickness is given, that is 25 into 10 to the power of minus 6. This is what the 2 marks question guys. Okay, right. Now I have one more question related to welding guys. Okay, related to welding, one more question. I just read the question, so have a look on this. Two surfaces P and Q are to be joined together. So it is not much difficulty question, it's just a data, that means a memory based question guys. Okay, now let me explain you that. Two surfaces P and Q are to be joined together, in which the given process there is no melting surfaces of P and Q. Okay, now So let me explain you the question. Right. So two surfaces are there. Say first surface we say that it is a P, and second surface say that it is a Q, guys. Second surface it is called Q. Okay. Now the P and Q's two surfaces are going to be joined together. Two surfaces are going to be joined together. So by the welding process, Now here, but given the condition, whatever the welding process using for joining the P and Q surfaces, there is no melting condition given. There is no melting condition given. Yes, guys. There is no melting takes place while joining the P and Q surfaces. Okay, P and Q surfaces, there is no melting takes place. Then the options are given, that is arc welding, and B is spot welding, and brazing, and D option is adhesive welding. Right, these are the processes are given. Okay, now it is a simple and memory based question. So if you read that our notebook, or else if you properly do that, then here what happened now? See, here arc welding, melting takes place. Spot welding also melting takes place, right? But these two surfaces are not going to be melt. Okay, but here what happened? These are going to be wet. In brazing. So that is why this is also option is also not correct. Now adhesive welding is a solid state welding. There is no melting going to be takes place. That is why your answer is adhesive welding. Okay, so hope you understand the solution, guys. Okay, yeah, thank you. Another faculty will come to teach you one more question. I have opened the mic.
Hi everyone. Hi, hello everyone. How was your paper, Abhinav? Utsav, tell me, how was your paper? Okay, I came up with some questions from thermodynamics, right? And we'll discuss the solutions. But before that, Aditya, Brijesh, tell me, how was your paper and how was your experience? Okay. Right, so first I will discuss the question of thermodynamics, right? Yes, guys. Okay. First I will discuss the question of thermodynamics, okay? So question is like this. A heat engine actually they have provided which extracts the heat QH, okay, from a reservoir, okay, right, at 1000 Kelvin, right, and rejects, okay, rejects heat at 100 Kelvin, right? So I think you have seen this question, yes or no? Tell me guys, fast. So this was the question, and while producing W work, while producing W work. Okay, everyone. Now they're asking the combination, which combination will be correct. Okay, so various options they have given. I'm writing the options, and please tell me if you have solved this question. Okay, so option A, QH value they have mentioned 2000 joule, QL value 750 joule. Okay, and this work value is 1250 joule, right? So this is option A. Option B, QH 6000 joule, QL value 600 joule, right? And this work value is 550 joule, right? Now see, option C they have mentioned QH value 2000 joule, right? And QL value 500 joule, and the work they have mentioned 1000 joule, right? Now option D, last option, QH again 6000 and QL value is 500 joule, and finally the work value is 5500 joule. So tell me everyone, which option will be correct? Abhinav is saying option B. Okay, Abhinav, you're telling the option B. Okay, we'll see the solution, and everyone please mention your answer. Mention your answer everyone fast. Okay, actually what they have asked in this question, they've asked which combination is allowed, for the heat engine, right? So see, whenever a heat engine is given, you should understand a very basic concept of Carnot engine, right? So I will tell you. So let's suppose this is a heat engine we are having. Okay, so this is a reservoir, high temperature reservoir. This is a low temperature reservoir. So obviously we'll call it TH. Notation we will use here, the lower temperature reservoir, and this is the work. So as far as a Carnot heat engine is concerned, so maximum work output will be there. Okay, yes or no? Now, so see, this is the QH heat transfer from the high temperature reservoir. This is the QL heat transfer to the low temperature reservoir. Now you should understand, first of all, efficiency of Carnot engine, right, is what? 1 minus TL divided by TH, right? This is the point you should understand. Regarding Carnot engine, what are the relations that you should understand? Carnot efficiency, right? Then Clausius inequality. Okay, Clausius inequality, it should be less than equals to 0, right? And if I have to find out the work, because in the question they have given the work as well, right? So easily I can say the work possible in the maximum Carnot engine, it would be QH minus QL, right? So these are the relations that you need to understand, right? So now if you see the options here, the QH and QL they have mentioned. Now just see the option 1, 2000 they have given, 750 they have given for the QL value, and the work is 1250. So just observing this relation here, QH minus QL, directly option A will be the correct answer. Option A will be the correct answer here, guys. Abhinav, you are telling B, but try to understand whether the work will be equals to 550 or not. Just check the value 6000. If you subtract the 600 from the 6000, what you will get? 550 or not? No, you will not get that value. Are you getting? Abhinav, option B is not correct here. Option A will be the correct answer, because the work, see, we have written the formula, work equals to QH minus QL. Okay. So just check whether the option B is satisfying this relation or not. No, it is not satisfying. So how the option B will be correct? Now, why you are saying that option B will be correct? Just because you have used the efficiency relation. You should also consider whether the work will be there or not, like 5500. Okay. Correct. Now, Abhinav, option A will be the correct answer here. Option A will be the correct answer. Abhinav, if that the case, if options are different, please mention in the chat box also what are the different options. But as far as the question that student has provided, based on that, the option A will be the correct. Okay, if there is any correction required in the question, please mention in the chat box, right? Because these are the questions that you guys have provided. Okay, so we are solving those questions only. Okay, so based on the question you have provided, option A will be the correct answer. But try to understand these three relation has to be what satisfied only. So let's suppose efficiency is correct, but let's suppose the work is not equal to QH minus QL. How the option will be correct? Okay, everyone. Right, oh, okay, we'll see the option D. Yes, everyone, QH 6500 is there. Okay, now see, this is 6000 and this is QL, this is 500, right? So here 5500 yes, that is correct. Now you should also understand whether this relation is correct or not. Clauses inequality relation, you should also satisfy this relation, whether this clauses inequality is valid or not. Are you getting the point? See, what is the clauses inequality? I will write here, QH minus TH minus QL divided by TL less than equals to 0. Please check this relation, everyone. Deepak, Abhinav, please check this relation on option D as well and tell me, right? Now, in a meanwhile, we'll solve the second question here, again from the thermodynamics, and again very easy question from the ideal mixture relations. Again, very easy question from the ideal mixture relation. So thermodynamics questions are what very easy in this GATE examination, right? So see, everyone try to understand, this is the relation number 1, second relation, third relation. So if only this relation is satisfied, we cannot say option will be correct. We have to understand efficiency, clauses inequality and this relation. All these three has to be what verified, then only we'll say the option will be correct. Okay, now we'll move on to the next question. Everyone, next, see, in the next question a ideal gas mixture was given. Okay, so actually a gas mixture is given. So let's suppose a container is there in which gas is provided, which is gas X, okay, and there is also a gas Y, right? So it is two ideal gases are there, and if two ideal gases will be there, then definitely an ideal mixture will be there. Okay, everyone, right? Now see, try to understand pressure what they have given for this, 100 kilopascal, right? Volume 10 meter cube, temperature 300 Kelvin, and mass for the X gas they have given as 2 kg, and what they are asking, mass of Y gas. This is they are asking the mass of Y gas. Okay, ये वाला easy था. Yes, obviously, see, this is very easy. The mixture of ideal gas is nothing but ideal gas only. We'll apply the ideal gas relations directly. So now they're asking the mass of gas Y. So what equation, ideal gas equation you will apply here. Okay, now see, this is the data. Obviously, ideal gas equation is what? Ideal gas equation, P into V equals to N R bar T. Now you should understand R bar is what? The universal gas constant. R bar is what? Universal gas constant, right? Value is what? 8.314. That is what given in the question itself, right? So we'll apply this equation. Now see how we'll apply this equation. So pressure into volume equals to N. N is the number of moles, R is universal gas constant, temperature T. Pressure they have given as 100 kilopascal, right? Volume 10 they have given. Now number of moles will be what? Number of moles of X gas plus number of moles of Y gas, right? And universal gas constant. Now universal gas constant will be what? 8.314 kilojoule per kilomole Kelvin. Temperature, what is the temperature? Temperature is 300. If you have solved, please tell me the answer. If you have solved, please tell me the answer. Abhinav, if you have solved, please tell me the answer. What answer you will get? What answer you will get? So now you should understand number of moles is actually equals to mass divided by the molar mass. Mass divided by the molar mass. Now actually in the question, see, if you see, just a second. Yes, number of molar mass is already given in the question. So for X, they have given 10, and for Y they have given 20. Yes, kg per kilomole. Right, the molar mass is given in kg per kilomole. 10 and 20 they have given. Right. Now, see, this is value 100. Okay, this is the value 100 into 10, and we'll replace Nx with Mx plus molar mass of X plus My mass of Y divided by the molar mass of Y. So like this relation we will utilize in order to solve the mass of Y gas. Tell me what answer you are getting. 20 you are getting. No, tell me the answer of the mass of Y gas. Final answer, please tell me what is the final answer of the Y gas, mass of Y gas. They are asking what the mass of Y gas, right? So see, we'll put the values here. It becomes 1000, right? Mass of X gas is 2 kg. 2 divided by molar mass is what? 10. 2 by 10 plus mass of Y gas that we need to find out, and it is given as what? 20. Okay, everyone. Yes, Shivam Kumar, absolutely correct answer. 4.018 something actually you are getting. Yashpal is saying aptitude 15 marks easy. Okay. So, according to you, please mention, according to you, what is the level of paper, because whatever the student has suggested us, they have tell the paper is around a moderate level only, right? Not that much tough. Okay. So, using this equation, Shivam Kumar, you got the correct answer. If I write the final answer here, the mass of Y will be what? 4.018 kg. This is the answer, final answer. Okay. This is the final answer that you will get, mass of Y gas. So it is again a very easy question. Just you need to apply ideal gas equation, PV and R bar T. But you should remember what is pressure. Pressure you need to put in absolute sense. Kilopascal I have put, so obviously R value will also be in kilopascal. Just take care of the units, very important. See, even if you know the formula, it doesn't guarantee that you will get correct answer. Obviously, yes or no? If you don't put the values correctly, you will not get the answer. Even if you put the values correct, but the SI unit is wrong, the units are wrong, you will not get the answer. Ayush, yes. Okay, great. So what does it mean? If you prepare well, definitely you will get the maximum marks, right? So Ayush, you should understand, if you prepare well, no, definitely you will get the maximum marks, right? So in the next year also you can prepare, right? If you are not getting the good marks in this year, but if without preparing you are solving more than half of the question, that is what very good thing, right? Now moving to the next question, guys, moving to next question. Yes, next question. Next question will solve from different subjects, strength of material, right? So next question, guys. So in the next question, actually a torsion question is there. They are asking the power. Now try to understand, everyone. The length of the shaft they have given as 1.5 meter. Diameter they have given 100 mm, right? And G value they have given as 80 gigapascal. Okay, modulus of rigidity they have given. RPM they have given as 500 RPM. Number of revolutions they have given. Angle of twist they have given 0.5 degree, right? Now what they are asking, power. They are asking the power. Now you should understand, they are asking the power. They have given every parameter. Just by the use of torsion equation, you will be able to solve this question. Yes or no? Tell me the answer, guys. If you have solved this question with the help of torsion equation, you can easily solve this question, right? So I will directly see. First of all, you should understand which formula you need to apply here. Power 2 pi nt by 60. Simply, we'll get the answer in what? So actually, this formula comes from what? Power equals to torque into omega. Omega is the angular velocity. T is the torque here. Now, first thing you should understand, we need to calculate torque in order to find out what? The power. Omega we can easily calculate because the RPM is given. 2 pi n by 60 is nothing but angular velocity only. Yes. So, how you will calculate the torque? Remember the torsion equation that you have learned in the strength of material subject. Right. So, in the strength of material subject, the torsion equation that you have studied. What is the torsion equation? Torque divided by the polar modulus equals to shear stress divided this r radius g theta divided by L. So, this is the torsion equation from which you can easily calculate the torque value. Now, see, torque value will be equals to, see, I will equate this one and this one. So, you will get g theta into j divided by L. This is the relation. Now, even if you know the formula, sometimes if you don't put the values correctly, you will get the wrong answer. That is where the most of the students will do the mistakes. Right. So, remember the theta they have given in degree, we need to convert it into radian. We need to convert it into radians, right? Remember this point. So, now see, theta they have given 0.5 degree, right? So, we need to multiply what? Pi into 180. Pi into 180 we need to multiply, so that we'll get the answer in radian, because 180 degree equals to pi. So, 1 degree will have what? Pi by 180 radian. So, 0.5 multiplied by pi by 180. That is what the radian, in terms of radian we are having. Just use the relation that just now we have written, the formula of the torque. What is the formula? G theta into j. Okay. So, we will write here also. Now, we will put all those values. G value is what? 80 into 10 to the power 9, because it is gigapascal, into theta, that is 0.5 into pi by 180, right? And what is j value? Polar modulus pi by 32 for the shaft, okay, into d to the power 4. So, but remember they have given in mm, so it will be equals to 0.1 meter, right? Okay, everyone. Now, divided by the length also. In the denominator, what will be there? 1.5. That is what the length. So, this is the value of g, this is the value of theta, this is the value of j, and this is the value of the length. Finally, tell me the answer. What will be the value of the power? Just calculate the torque, put this value in this relation. And RPM already given in the question. What answer you are getting? Everyone, please tell me fast. What answer you are getting? Just putting this values, what answer you will get? Okay, everyone, please tell me. See, the torque value you will get around, I am writing the answer here, 4569.26 Newton meter torque you will get, okay, and this was this value you have to supposed to put in this formula, and finally you will get 239.24 kilowatt. In terms of kilowatt, you will get answer like this. Shubhankar is saying paper was very easy. Okay, very good, Shubhankar, if you found the paper as easy. So, definitely you will be getting a good marks. Okay, what marks you are expecting? Can you tell me? Shubhankar, please tell me what marks you are expecting. How much questions you have attempted? Right, just tell me how much questions you have attempted, right? So, the final answer of power is 239.24 kilowatt. Clear, everyone? Please calculate the values, okay? So, next one more question is there from the theory of machine. Okay, next question I will discuss from the theory of machine. Guys, tell me, theory of machine question next. So, see, in the theory of machine question, what they have given. This is one spring, this is another spring. This is the mass we are having. Okay, so this is the system. Spring having stiffness K, okay, like this they have mentioned. Now, so now they have mentioned if mass equals to 20 kg, right, stiffness value equals to 1000 Newton per meter, okay, and they have mentioned it vibrates, then the free vibration, obviously free vibration will be there, right? Okay, free vibration will be there. What they are asking, free vibration, time taken. Okay, they are asking the time taken time taken by the block to complete 10 oscillations. Okay, so that was the question, guys. If anyone has solved, please tell me the answer. What answer you are getting in this question? Very simple, straightforward question they have asked. Again, two springs were arranged parallelly, so equivalent stiffness formula you need to apply here, right? The mass is given, stiffness is given. Now they are asking time taken by the block to complete 10 oscillation. Free vibration question it is. So in the case of free vibration, directly you can apply the natural frequency formula under root k by m, right? So I will write the solution here. Everyone please see. Omega n value is what? Under root k by m. Now which k you need to put here? Equivalent stiffness. What is the equivalent stiffness you are having? See, parallel springs, arrangement of the spring is what? The parallel. So k plus k. What is the value of k? 1000. So finally you will get the answer of the equivalent stiffness as 2000 Newton per meter. Now tell me, this is the question they've asked. Time taken to complete 10 oscillation. Now, first of all, calculate the time period for the one oscillation and directly multiply that 10. You will get the answer. So what is the time period of the oscillation? Can you tell me? What will be the time period of oscillation in this case? See, first of all, you need to understand the formulas. Sometimes you will forget the formula. See, if I talk about the frequency, it will be what? Omega n. See, omega n by 2 pi. Time period. See, you should remember these formulas. Time period will be what? 1 upon this frequency. This frequency in terms of hertz, this is what the cycle in seconds. Time period in seconds. So 2 pi divided by omega n. Okay, 2 pi by omega n you will have. Correct? Yes or no? What is the final answer you are getting? See, these formulas you need to apply and you will get the answer. The time required for the 10 oscillations. Ayush, tell me, put the values in the formula and tell me the final answer. Put the values and tell me the final answer. Time period is what? 1 by Fn. Fn value is omega n upon 2 pi. So this is what in terms of hertz. Number of cycles per second. This is the time required for 1 cycle and they are asking for 10 cycles. So see what will happen. Time period I will calculate. What is the time period formula here? 1 by Fn. Now it will become 2 pi by omega n. It will become 2 pi by omega n. Now see. First of all, I should calculate the value of omega n. K equivalent is what? 2000. What is the value of mass they have given? 20 kg. So, what is the value of omega n from here? 10. Simple. 10 you will get. Okay. So, here 2 pi by 10. So, this is the time required for one oscillation or I can say one cycle. So, for 10 oscillation, for 10 oscillation, it will be what? 10 multiplied by 2 pi by 10. So finally you will have the answer as 2 pi. You will have the 2 pi as the answer. So that much time will be required, guys. That much time will be required. And if you calculate 2 pi value, it will come around 6.28. It will come around 6.28 seconds. So see, the question is again very easy, but you need to be what? Very careful while putting the values, right? K equivalent, parallel combination they have given, frequency. You need to remember the formulas as well as you need to remember the meaning of that formula also. So this frequency is what? Number of cycles per second. This is what time required for one cycle. Number of cycles in 1 second, this is Fn. Number of time required for one cycle, this is time period, right? Like this you have to take care. Okay, Ayush, see, always remember whenever multiple spring is there, you need to take the equivalent stiffness. You need to take the equivalent stiffness only, right? So parallel combination is there, you need to take what? Equivalent stiffness. That is what the formula K plus K. right? So I hope this solution is clear. Now the next faculty will come and they will discuss some more questions with you. In a meanwhile, if you have any memory based question, please share in the comment box also, in the chat box also, right? In a meanwhile, please share the questions, guys, and we'll be solving all of those questions for you. Okay, everyone, please share the session as well. Hello, my dear friends. How are you? Hello, my dear friends. So let me know what was your experience during the examination. Tell me, how was your paper? Please let me know. What do you think? What do you think you are going to get? Tell me, how was your experience? My dear friends, I am here with some HT questions, IE questions. Although IE questions were not very much, they were not, hardly 2 or 3 I could find out, but still, let's see. So my dear friends, if I talk about HT, there was a question from, it was for 1 mark, and he was saying that, just a minute, he was saying that some counterflow heat exchanger was given and the inlet of both the fluids, let one was given as 350 Kelvin and the inlet of the other fluid was given as 300 Kelvin. Okay, now heat capacities were given like 100 watt per Kelvin. Fine. Effectiveness was given by 0.5 and he was asking what actual heat transfer, yes or no? Did you guys solve this question? Actual heat transfer. So my dear friends, you know that effectiveness is given by what? Q of actual divided by Q of maximum, yes or no? Then Q of actual would be what? M dot Cp of the lower fluid, and then okay, Q of actual we have to find out, and Q of maximum would be what? M of Cp of the lower fluid and into the inlet of one and the inlet of other, yes or no? So Q of actual you have to find out. So Q of actual would be what? Effectiveness is given as 0.5 and MCP lower is what? 100, and the inlet of both the fluids is 350 minus 300, yes or no? My dear friends, they are asking question in kilowatt. They are asking question in kilowatt, but this will be in watt. So finally you have to divide by 1000. And if you solve this completely, I think you are getting 10 as the answer. Yes or no? You can confirm with me. Are you getting 10 as the answer? Yes or no? This is for 1 mark. This was for 1 mark NAT HT question. So it was a good question. For 1 mark, it was a very good question. And I hope that you people have solved this correctly. My dear friends, there was a question of 1 mark. There was a question of 1 mark which was saying that, which has see, I've come with all the rough data. I've come with the rough data, although they're all correctly. They're all correct. I'm not writing the complete question. I'm only writing the important points. There was a question in HT which he has mentioned that it is 1D, it is steady state, and there is no heat generation. There is no heat generation. So what was the, how would the graph look like? How would the graph look like? My dear friends, either it can be this one or either it can be this one. Two can be possible. Either it will be this one or it will be this one from 0 to L. Yes or no? it will be straight line only. From 0 to L, it will be straight line only. You cannot simply say that, sir, this will be the graph. No, it can be this also. So it was an MSQ question. It was an MSQ question, and this both are correct answers. Now, the one in which graphs are there, quadratic equation, all these things are there, that would not be the answer. My dear friends, yes or no? So this is an MSQ question, and I hope you have got this correct as well. Fine. So let me see if I have some other questions as well. Yes, a very good question of lumped analysis was being asked. A very good question of lumped analysis was being asked, my dear friends. Do you remember that question or not? It was saying that a plate has been shown as this, and D is its length, and from both its sides ambient was there at 300 Kelvin. Ambient was there at 300 Kelvin. This was given as D by 2, and this is the mean temperature. My dear friends, the question said that in which of the following cases lumped analysis is possible. Okay, Ayush is saying, sir, can we get half marks if we select one option? My dear friends, MSQ, you have to select all the correct answers. Yes or no, Ayush? Or both the correct, you have to select both the options. Yes or no? Okay, but good question anyway, funny question. Anyway, yes, let's come to this lumped analysis, my dear friends. In lumped analysis, they were saying that in which of the cases, in which of the following options, lumped analysis is applicable. Lumped analysis is applicable. My dear friends, can anyone tell me what is the criteria for lumped analysis? The criteria for lumped analysis is simple. Bio number should be less than 0.1. Yes or no? Bio number should be less than 0.1. Now, what is bio number? Bio number is HLC by K. HLC by K. Can anyone tell me what is LC? LC is nothing but the characteristic length. Characteristic length. Characteristic length. Very good, Abhinav. Very good, Abhinav. Very good. Very good. Now, characteristic length. What is characteristic length? Can you tell me? What is characteristic length? Volume by area. So, volume is A into L. And what will be area? My dear friends, see, on both the sides of this surface, the fluid is flowing. So, it will be 2 into A. So, A and A gets cancelled, and L by 2 would be the characteristic length. L by 2. Now, what is L? Over here it is D. So, D by 2 is the characteristic length. D by 2 would be the characteristic length. Yes or no? So, your bio number becomes what? HD by 2K. HD by 2K. HD by 2K. HD by 2K would be the characteristic length. So, there were 4 options. In 4 options, you have to select that for which values of HD and 2K, your bio number is going to come as less than 0.1. So, my dear friends, in the first option, the bio number was coming around 500. So, this would not be the answer. My dear friends, I am not going to put all these HD and K values you have with you. In the second option, okay, let me write HD by 2K. H was 100, D was 1, 2 into K. So, it was 0.5. No, this would also not be the answer. In the third case, the bio number was HD by 2K. So, it would be 10 into 1 into 10 to the power minus 3 by 2 into 100. It was very, very less than 0.1. You can clearly see. So, yes, bio number was applicable. And in the fourth one, HD by 2K, 100 into 1 into 10 to the power minus 3, because millimeter, it was given in millimeter, 2 into 10 to the power 3. It is also less than 0.1. So, my dear friends, C and D was your correct option. Now, you have to there means 2 are the correct answers. 2 options are correct. So obviously it is an MSQ question. My dear friends, have you got this right or not? Let me know. Have you got this correct or not? Have you got this correct or not? Okay, there was a question of shape factor. Anyone can tell me? There was a question of shape factor. There was a question of shape factor. Yes or no? There was a question of shape factor, view factor. Whatever memory I have, based on that I am trying to solve this question. This question said what? The diameter was given as D and this was given as H, I think, and this length was given as L, and it was saying that this is a cube, this is a cube, this is a cube, yes or no? And this was S, this this surface, it was said to, they told to take it as S, and he was asking f of SS, yes or no? F of SS he was asking. So if I take 1 as the cylinder, if I take 1 as the cylinder and 2 as the cube, so he is asking f of 2. Fine. So my dear friends, if I consider this is 1, this is 1. So do we know this thing? F of what is f of 1 1? F of 1 1 would be 0 because it's cylinder. F of 1 2 would be what? 1, because all the heat has been going to the cube itself. So can we apply reciprocity? A1 F12 is equal to A2 F21. But before that, what is the area of 1? What is the area from where heat is going? So it would be the top 2 surfaces and the curved surface. That means the pi dh and pi by 4 d square pi dh and pi by 4 d square into 2. So pi dh plus pi d square by 2. Yes or no? Pi d square by, this one and the curved one. So this is A1. What would be A2? A2 is nothing but 6 L square. 6 L square. So if 1 2 is 1, so what will be f of 2 1? F of 2 1 will be A1 by A2. It is pi dh plus pi d square by 2 whole divided by what is A2? A2 is 6 L square. And my dear friends, he is not asking f of 2 1, he was asking f of 2 2. So f of 2 2 is what? 1 minus by summation rule, it is f of 2 2 will be. Very good, Ritik, excellent, excellent, very good, very good, very good, very good. So this will be your correct answer. Very good, Ritik, very good. So my dear friends, this was again, a very doable question. So overall what I felt is that I think I've discussed all the HT questions, if I remember. Overall what I felt is that the HT questions were on the easier side. They could have made it tough, like the last year if I compare, there were some difficult, or I would say trickier questions from HT, but this time they have made it easier. But don't be happy, because manufacturing was on the tougher side, I would say. So I think they have balanced well, right? And you can let me know your experience as well, that's not the problem. My dear friends, I think there were not many questions from industrial engineering, if I can remember. One question was there, it was saying that for IE, for industrial engineering, one question was there, it was saying that this is the cost axis and this was your Q axis, quantity axis, and he has given 4 curves like this. He has given 4 curves like this, yes or no? And he was saying this is P1 and he was saying this is P3, he was saying this is P2 and this is P4. So yes, the P1 is the curve for total cost, then the P2 would be the for setup cost. No, for holding, this is for holding one. P3 is for setup. Why setup? Because ordering cost also looks like this, so it would be setup cost, and P4 was for production cost. P4 was for production cost. See, even if you have no idea about this production cost, just by the knowledge of P1, P2 and P3, you can guess the correct answer. Yes or no? So it's not needed that you know all the type of curves. One or two is, if you know, it would be fine. So I don't think any more industrial questions were there. So I think I have discussed all the questions with you guys. Just a minute. Yes, I think I've discussed all the. Okay, one more question of industrial was there, my dear friends. One more, yes. One more question of industrial engineering was there. The graphical question. How many of you have done it? How many of you have done it? This question, and can you tell me the answer? Can you tell me the answer? One was x1 less than equal to 45, then x2 less than equal to 50, then x1 by 60 plus x2 by 60 is less than greater than equal to 1, and x1 by 30 plus x2 by 150 is less than equal to 1, and he was saying which is the correct feasible region. How many of you have done it, and can you tell me the answer? Can you tell me the answer? How many of you have done it, and can you tell me the answer? This is for the third one. And the fourth line will go something like this. The fourth line will go something like this. So my dear friend, he was saying that this is one region, this white one is one region, this shaded one is region 2, and there were many regions. So he was asking which of it is the feasible region. So my dear friends, the white one which I have drawn is the feasible region, and in that case it would be Q. It was named as Q, so Q would be your feasible region. Yes or no? Because at the same time it is satisfying all the constraints. Very good, Yashpal, very good. So my dear friends, I think 2 IE questions were there and 4-5 HT questions were there, and they were on the easier side, doable side. But my dear friends, you can let me know how was your experience overall. What are you thinking? What do you think is your marks going to be? And similarly, all the questions are going to be discussed one by one. So my dear friends, you can let me know if you remember any memory based question, my dear friends. So my dear friends, please stay tuned. Faculties are going to come and they are going to discuss all the questions. Thank you very much, my dear friends. Stay tuned.
Hello everyone. Once again, welcome to IMS Gate Academy. So now I'm having more questions of engineering mathematics and general aptitude. So let's approach to the questions, guys. So let's start with the very first question of engineering mathematics. This question is from calculus, the vector calculus question. As I used to say so many times, dear students, that we can expect one question from vector calculus. In vector calculus, we are having two things. First is three operators, gradient, divergent, curl, and second is 3 theorems, Green, Gauss and Stokes. So this is the question we can use. In this question we can use Gauss divergence theorem. So let's approach the question. So let's see the question. Given a vector field B xyz is equals to xi cap plus yj cap minus 2zk cap, okay, is defined over a conical region having height 2 and radius 3 and axis along z as shown. Okay, it is given. I will show you the figure also. The base of the cone lies in the xy plane and centered at origin. Okay, then if n cap denotes the unit outward normal vector to the curved surface S of the cone, then the value of the integration S b dot n ds. So actually n cap, okay, b dot n cap ds. So here we can easily use the Gauss divergence theorem. I'm going to show you here something. So the diagram, I can just write down the naming here as this is the z axis, this is the y axis, this is the x axis, this is the height of the cone, okay, and this is the radius r we are having also. So we can and this is the origin O. So as now it does not make any difference whatever the figure we are having, whatever the radius and height we are having, we can do this question directly with the help of the Gauss divergence theorem, my dear students. Had you approached it, if any one of you approached it, then just write down the right answer or whatever the answer you got in the comment box. I want to see what is your result. So here we can see, first of all, when I talk about this one, as we know very well, this is the question of Gauss divergence theorem. Whenever we are having the question like this one, we can approach the question in the form of del dot, if I'm having f, del dot f dv. So this is the statement of Gauss divergence theorem. So I'm going to use here the divergence theorem, and with the help of this theorem we can easily solve the question. Okay, first of all, we can see the value of the function. The function is given to us as b cap is equals to x I cap plus y j cap minus 2z k cap. Okay, if I want to approach this question with the help of the Gauss divergence theorem, then I have to find out the divergence of the given function. So let's find out the divergence of the function del dot b cap. So when we will find out, or the b vector, okay, when we will find out the divergence, so divergence is nothing but if this is b1 del b1 by del x, okay, del b2 by del y and del b3 by del z. So I have to do partial differentiation of this one with respect to x. It will give me 1, with respect to y 1, with respect to z minus 2. 2 minus 2 शून्य. Beta, the value of divergence is 0. It means if I will put here the value del dot b vector, here in this case, suppose I'm having the vector as in b. So if I will put the values here, the complete quantity will become 0. So it will be 0, because 0 into whatever the volume, if we will put, then does not make any difference. So that's why we can write down the correct answer as in 0. So this was a numerical answer type question. The weightage was 1 mark of this question. So we can directly write down the answer as in 0. So this is the question which we can solve with the help of the Gauss divergence theorem. I hope this is clear to each and every student. Now let's approach to the next question. We are having one more question. So let me write down that question also. So yeah, this is the question, and this question is having the weightage again 1 mark, and this is also a NIT. Okay, so the question is a linear transformation. A linear transformation maps a point. Linear transformation maps a point xy in the plane, xy in the plane to the point x cap y cap, to the point x cap y cap as per x cap is equals to 3y and y cap is equals to 2x. We are having these things, and it is asking about then the disk x square plus y square is less than is equals to 1 gets transformed to a region with an area equals to what? So let's approach it, guys. I want to see the comment box also. So there should be a reply in the comment box also. You guys should reply every time. You have to reply. So yeah, very good. Someone is there. He is asking about the 0. 0 is for the previous one or for this one? Let's approach it. No, for this one we don't have the answer as in 0. Kanhaiya. Okay, let's approach it. I will tell you about this one. So we can make the question as we can make the question right now. The question we can see as this is the equation of a circle. Okay, we can use from here. Let me write down 6 pi. Okay, 6 pi. If this is an NAT, then we have to write down the value of pi also. Very good, shabash. Okay, let's approach it. So we can write down as first of all it is given to us x square plus y square less than is equals to 1. So actually they are giving us a circle. Okay, we are having a circle. It is nothing but x square plus y square is less than is equals to 1. This is my x axis, this is my y axis. Okay, if this is the circle which is given to me, we can see the circle. Right now they are asking about, okay, they are giving us the few important points also. So we can use these points in the given equation. So it is given to us x cap is equals to 3y and y cap is equals to 2x. From here beta I can write down the value of y which can be x cap by 3, okay, and value of x which can be y cap by 2. So I can put these values in the equation. If I will put the values of it is not 1, it is 36. It is not 36 beta. Let's approach it. Is it here we are having 36? No, it is 1 only. It is 1 only. It is 1 only. Yes, this is 1 only according to me. Whatever the data I am having, this is according to me 1 only. So when we will approach it, so it will be value of x, it will be y cap by 2 whole square plus x cap by 3 whole square is less than is equals to 1. So we can see that this is nothing but the equation of an ellipse. So we can convert this equation into the ellipse only. So the circle converts into the ellipse. We can see this thing. So this is the equation of an ellipse which you can see like here. Okay, let me write down. Let me make the ellipse in the different color. So this is the equation of an ellipse which we can see from here. Okay, this is the ellipse for me, x and y. So we can easily solve the equation from ellipse now. Yeah, I'm continuing here. So as it is asking about the region with an area. So we have to find out the area. Then the area of ellipse is equals to pi AB. Okay, pi AB. We are having the A. Okay, I can show you here the A and B, the length and. So this is nothing but the 3 and this is nothing but we are having second thing is 2. So we are having 3 and 2 both the things. So we can use here and we can go for the A and B. So the area will be pi AB. So pi into 3 into 2. It will give me 6 pi. We can put the value of pi as in 3.14. After putting the value, it will give me 18.84. It will give me 18.84 beta. So this will be my answer for the area. And this is a numerical answer type question. So we can write down the answer very easily. I hope this is clear to everyone. Yes. Very good. So now we are expecting these type of questions. As I used to say that we can have a question from vector calculus. Here we are having, okay, in similarly in EC electrical, okay, for the civil students, for IM students also there will be a question from the vector calculus also. Now one very easy question is there for the from the probability. As I used to say that the binomial and Poisson both distributions are important. So here we are having one question from the Poisson distribution. I'm going to write down the question was very simple. So let me write down that question. I'm having the question here. So the question is the probability of defective component, probability of defective component is 0.015, okay, in a box of 200, in a box of 200 pieces, okay, follows the Poisson distribution. It follows the Poisson distribution. As we know very well, whenever the question comes from the Poisson distribution, they will always mention about the question that here the Poisson distribution is applying. So it will always mention in the type of questions of Poisson. So they are asking about, then find the mean and variance. Find the mean and variance of Poisson distribution. Okay. So that we know very well कि in these type of questions, okay, this is a MCQ first of all. We are having options, but right now I don't have options, but we can make the options like this. Root 3. Okay, second option can be 3, 3. Third option can be 1 by root 3. Fourth option can be 1 by 3. So let's approach it. Okay, I'm not having the exact options. Okay, these are the memory based questions, so you can relate to the options. If you will not write down, again the question is MCQ only. So here it is asking about the mean and variance. So we know very well, beta, this is a very simple concept which we learned 100 times in our classroom. As I used to say, beta, that these type of questions are very easy and directly approachable, because now it means we already write down. As I used to say that these type of things you have to write down as in keynotes, small notes. Okay, so we know very well for the Poisson distribution, mean and variance are mean, standard deviation and variance. Okay, standard deviation will be, we can calculate, but mean and variance will be equal always, and with the help of the variance we can go for the standard deviation also. But here it is asking about only mean and variance. So when we go for the mean of Poisson distribution, that is nothing but lambda n into p. This is the same thing for variance. So variance is also is equals to NP. So for mean and variance of Poisson distribution, the result will be n into p only. Yeah, very good. So when we will approach it, here we are having the value of n as it is given to us in the question. The n is total number of things. So it is 200. So we are having n as 200 and probability p as 0.015. We can easily find out the value of lambda. It will be 200 multiply with 0.015. It will give me 3. So lambda is equals to 3. We can easily solve the value of lambda, which is 3. So the mean will be 3. Hence the variance is also equals to 3. So the mean and variance both will be 3. We can see the right answer will be this one, in which both the results as written, both the result has been written as 3 and 3. Yes, clear everyone? We can easily solve the thing. So we can see the result as 3 and 3. Yeah, very good. Kanhaiya, shabash. So this is the very easy question we are having. Okay, 1, 2 and 3. We approached the 3 questions from the engineering mathematics. Now let's go for the few questions of general aptitude also. I'm having the questions from general aptitude. Let's start with the very first question of general aptitude. So I'm going to write down here the name of the subject so you will not be confused. General aptitude. Okay, let's start from here. So this is the very simple question of general aptitude. We are having the question from the rectangle perimeter, right? So this is an NAT numerical answer type question, and the weightage of this question was 2 marks. Let's start from here only. The question is the smallest perimeter that a rectangle with area of 4 square units can have is what? Okay, we need to find out from here the perimeter of the smallest perimeter. Okay, that a rectangle with area, so we need to find out the smallest perimeter of the rectangle. Now, had you approached this question, bachcho? Had you approached this question? Yes, tell me. Had you tried? Okay, I'm going to solve the question. So, yeah, let's approach it. So, as the question, as we know very well, that the area of a rectangle, let me write down on the next slide. So, the area of a rectangle is, okay, area and perimeter. We should know about both the things, because it is asking about the area and perimeter. It is given to me both the things. Yashpal is writing answer as an 8. Shabash, very good, absolutely right, very good. So we know that the area of a rectangle, as it is given to me already, we know the area is given to us how much? 4 square units. So this is 4 square units. First thing it is given to us. Okay, they are asking about the perimeter, so that we know very well, beta, from here the area is nothing but the length into breadth, and the perimeter is nothing but 2 into L plus B. Now you are asking about the smallest perimeter. So first of all, now as I have to make the area of this rectangle equals to 4, so I can just check that suppose I am taking L is equals to 4 or I am taking B is equals to 1. I am just showing you something, because it is asking about minimum. So we can go for the, as we know very well that the area is multiplication of 2 numbers. So I have to find out those 2 numbers whose product is 4. So either I can go with the 4 into 1 or I can go with the 2 into 2. These are the only 2 possibilities for the area. So if we can check both the options, if I will go with the L and B as in 4 and 1 respectively, then beta, it will give me, let me write down here the area which is 4. If I will put as in this is equals to, now if I need to make this one, so I can say that the area must be equals to the perimeter. So this is 2 into L plus B. So we can go for the 4. Okay, and if I will put here the values 2, and if I will go for the L as in 2 and B as in 2, sorry, 4 and 1, so it will be 5 2 ja 10. So it is giving me the different things. So this will be not equal. I have to convert the area of rectangle into the smallest perimeter only. So that's why this is not possible. Yeah. Okay, very good. So all the very best. Go out, don't be in hurry. Okay, just read the questions very carefully. बिल्कुल कोई भी silly mistakes नहीं करना है. Just focus on the basics and concepts. Read the question, then approach it. Okay, and just be relaxed. So here this is not possible. So when we go for the 2 and 2 pair, when I will check this one for you, so we can check the area is 4 already. 2 into value of L and value of B, both I can put 2. It will give me 4 2 ja 8. Okay, why I am writing this is giving me this is giving me perimeter. We will not make it equal. So this is giving me perimeter as 10 and this is giving me perimeter P. Okay, perimeter as 8. So we can directly compare. The question is asking about the minimum value, beta. So among these two, which one is minimum? This one is only the minimum. So that's why we can go for the, you want the minimum perimeter or the smallest perimeter. So this will be the smallest perimeter. We can write down the smallest perimeter will be 8 meter. Okay, so the result will be 8 units. Whatever it is, the result will be 8 units. Yes, I hope this is clear to everyone, guys. Okay, I'm having more question. One question is from, yeah, this is a very good question. I'm having one question is from clock. Okay, very easy question from clock also. So the question is the minute hand and second hand, minute hand and second hand. Usually we are having in questions, okay, usually we do have in questions the relation between minute hand or hour hand, but this time it is given to us the relation between the minute hand and second hands. Okay, let me read the question again for you. So the question is here only. Yeah, this is a MCQ of 1 mark. Let's approach. So the minute hand and second hand of a clock cross each other. It is asking about how many times. Okay, we have to find out how many times between the time is given to us 9:15 a.m. and 9:45 a.m. Okay, on a day, and we are having options also: 15, 29, 30 or 31. The options can be up and down, but the options are like this. Very good, very good. Yashpal, Abhinav. Okay, absolutely right. Let's see this question. I'm going to show you with the help of the interactive clock. I'm having the clock here. Okay, as yeah, here I'm having the clock. In this question, it is asking about the time. We have to find out the number of times second hand will. Let's read the question again so that I will not come to here. The minute hand and second hand of a clock cross each other. We have to find out the relation between second hand and minute hand. How much time or how many times they will cross each other between the time 9:15 a.m. to 9:45 a.m. Now let's see. No, it is not asking about the time 100 seconds. Let's see here the time. We can see this is the 9:15, and this is the blue color. You can see this is the second hand, this is the minute hand, this is the hour hand. We have to find out the number of times rotations or these two cross each other. Right now this is 9:15. If I will go for the hold on. If I will go for the 9:16, I can see right now it is 9:15. If I will increase 1 minute, beta, this second hand clock will cover it, or they both intersect each other at one time. When I will go for the 9:17, again they will intersect 9:17, 18, 19, 20, 25, okay, 30, 35, 40, 45. I need to go up to the 45. So from here to here, we are having 30 minutes. As I can see clearly from here that the second hand or second hand and minute hand just cross each other in 1 minute, one time only. We can see in 1 minute, one time. When it is 9:15, it will be here. Okay, when it will be 9:16, this second hand will cross each, or these both hands will cross each other. So in 30 minutes, they will cross each other in 30 times only. Okay, there should be no confusion, because now when it will be, when the contradiction comes, when it will be at 10 o'clock. Okay, so when it will be at 10 o'clock, they will be coincide, so they will not cross each other then. So that's why we can say we have to identify only from 9:15 to 9:45, and hence we can see in the 30 minute both the hands cross each other 30 times, because in 1 minute they will cross each other only one time. I hope this is clear to everyone. So these type of basic questions surely we can see. So the answer will be 30 times only. As you can write down the result. Why 30 times? Because in one minute they will cross each other one time. So in 30 minutes they will cross each other 30 times simply. Right? So this is the answer. Now let's go for the more question. I'm having two more very good questions of general aptitude. So let's approach first this question, which is of the graph. So I'm going to show you the question. Let me write down the question here only. So the question is here. Yeah, this is a MCQ of 1 mark. This is a MCQ of 1 mark. So it is asking about the graph. Sorry, a graph is given to us. We have to identify the graph is of which function. Okay, it is given to us x. This one is y. This one is 0. This one is -2. This one is -4. Here it is 2. Here it is 4, and it is given to me as like this 2 and 0, again 2 and 0. Okay, so yeah, so this is again 2, and the options we are having as 2 minus mod x, second option mod of 2 minus x, third option mod of 2 plus mod of x mod, and the last option 2 minus mod of x of mod, and the range is given to us -4 to 4, which we can see the range is from -4 to 4 only. So had you approached this question, guys? Had you approached this question? Tell me. Okay, actually this is the simple curve. We should understand first thing. If now I'm having in options, I can see I'm having in every option mod x. So if I will make a graph of mod x, let me draw here. If I will make a graph of mod x, the graph looks like, my graph looks like, if I will start from here, suppose -2 is there and this is +2. Okay, if I will just take it like this, okay, this is the graph of, not this is the, let me make it simple only. So if I will make a graph of mod x, because this looks like the mod x, this is the graph of mod x. We can see easily y-axis and x-axis. This is the graph of mod x only. If we want to change it, I'm having right now mod x, and mod is the positive value only. If I want to change the center from here to here, so this will, if I want to shift it to -2, then it will be looks like here only. It will looks like here. So this is the graph of mod x -2. Right now we can see this is the graph of mod x -2 only. Yeah. Now if I will just shift it, because this is the center, so I just shifted it to the -2. If I want to miss, right now I can see my center is shifted to the in the positive direction of 2, right? So it is +2. My center is shifted to the +2. So I can see that this graph is actually shifted here only. This graph is actually shifted here only. So this is +2. So I can see from here to here this will be mod x, and from here to here it will be minus again. So this will be, right now this is the mod x -2. If I will make like this one, this will be the 2 minus mod x. But actually it is giving me the mod only. Because if I will just elaborate this one, the signs will be changed. So if I want to write down the result as a mod only, then the result will be right, beta. Agar hum isme mod nahi likhenge, then it will be wrong. From the available options, we can see 2 minus mod x is also there. But we are having, अगर मैं इसको shift कर दूं यहाँ पे, we are having the result as mod x -2. We need to find out, and when we will shift it again to here, so it will be nothing but 2 minus mod of x. So that's why my result is option D, which we can see very easily from the basic graph concept. Okay, yeah, very good. Who's that? Yashpal, Amar, Abhinav. Absolutely right. The result is option D. Okay, shabash. Now we are having one more question of general aptitude, and let me see the weightage of the question. I think this was 2 marks question. Okay, the question is of 2 marks MCQ, 2 marks question. Let's approach the question here. This is a 2 marks MCQ. Let me write down the question. This is from inequality p square minus 4q less than 4. Okay. Next is 3p plus 2q less than to 6. Then we need to find out the value of p plus q when p and q are positive integers. When p and q are positive integers as it is given to me. And this is a MCQ, so we are having options also 1, 2, 3 or 4. Let's see which option is right. Had you approached the question, tell me beta which one is right. Absolutely right. Who's that? Abhinav Yashpal. Yeah, bilkul. Absolutely right. The answer is 2. Surely. Bilkul sahi. 100%. The answer is true. 2. Shabash. Arshad also. Yeah, bilkul. It is 2. 2. Sauradeep. Yeah, it is 2. Shabash. Let's approach it. So we can approach the question as it is given to us. The thing we will start from here only. As it is given to us, p square minus 4q is less than 4. Haji. And it is given to us 3p plus 2q is less than to 6. Now I am going to use this concept only. Here I can write down the p square minus 4 is less than to 4q. This I can write down like this, and from here I can get the value of 4q. Okay, I can convert this one. So I can just change to p square minus 4 is less than to 4q, and from here if I will multiply the complete quantity with the 2, I will have 6p plus 4q less than to 12. So I can write down 6p minus 12 is less than to 4q. So if this thing is less than to 4q and this thing is also less than to 4q, so we can solve from here only. So I can write down by these two things, p square minus 4 is less than to 4q, so, and this is already less than to 6p minus 12. So can I write down p square minus 4 is less than to 6p minus 12? Yes, surely we can write down. From here now we will have a range of p, so that we can identify the value of p from here directly. Yes, exactly. Pawan, yeah, it is 2. Absolutely right. So beta from here we can get the range of p. So how we can solve it? So p square minus 6p, and it will be, when I will solve this, I am having already minus 4 minus plus 12 less than to 0. Either you can write down like this one. Wait a minute, we are having from here, we are having from here p square minus 4 and 4q we are having, that is 12 minus 6p. Okay, just hold on, I want to shift it here. So I can write down this one as in 12, or we can go for the 6p plus 4q is less than to 12. So we can go for 4q. So that we can write down 12 minus 4q. Okay, now it will be clear. So we are having not 12 minus 4q, 12 minus 6p. Okay, so now we can put the values from here. 12 minus 6p, it will be also beta 12 minus 6p, so that I can compare the things and it will be very easy to solve. We can write down the values as p square plus 6p minus 16, and it is less than to 0. From here I can have I am having a quadratic equation. हाँ, only एक ही satisfy करेगा. Yeah, you can go through the values also. अगर आपके पास surely options हैं तो आप values put करके भी check कर सकते हो. That is the best thing. So if I will go with the conventional method, तो मैं आपको पूरा बता रही हूँ, है ना. So I can go with the factors. The factors will be p plus 8, p minus 2, which is less than 0. So from here, by doing the factors of this one, from here I can get the value. From here I can get the range. That I can say that my p is lying between minus 8 to 2, and it is given to me p and q are integers only. positive integers. So from here we can conclude that P will be only 1 because the possibility of P will be 1. It is less than 2. It is not less than equals to 2. It is less than 2. So when we need to find out positive integer, so the possibility for P is 1, right? P plus Q is not 1. P is 1. Now the same thing, we are having the value of P. From here we can get the value of P very easily. Now we can use the concept and we can find the value of Q also from here, this one only. So this we are having as 4Q is less than 2, 12 minus 6P. We can put the value of P here. So it will be 4Q less than 2, 12 minus 6. It will be 4Q less than 2, 6. From here we can say that Q is less than 2, 6 by 4 or 3 by 2. Q is less than 2, 3 by 2, and we need Q also as a positive integer. So it is implying that Q will be also 1. So we are having P and Q both as in 1 and 1. We need to find out the value of P plus Q. So hence we can approach the result as in 2. So P plus Q will be 2. So surely we can write down the result as in P plus Q is equals to 2. So we can approach it very easily. Okay, so in this way we can solve this question, which is a 2 marks question. So surely this is a very good question, an MCQ. So you should know about this special thing where it is given that P and Q both are positive integers. So we can approach the question like this way. Okay guys, so right now I'm having these questions only. If I will find more questions, surely I will come live again with the more questions. I hope these questions are very helpful for you. Each and every solution must be clear in your mind, because if you are going to write the GATE exam either on tomorrow or on the next weekend, it will be helpful for you, beta. You should know about the paper, okay, just which happened. So you should know about the pattern which IIT Kanpur is following. You can see the paper very clearly. You have to read your question paper also very patiently, very clearly. Okay, just read the question clearly and then approach it. Don't be in hurry, don't be overexcited and don't be depressed. कई बार ऐसा होता है क्वेश्चन बहुत अच्छा हमको आता है, हम उसको देख के ओवर एक्साइटेड हो जाते हैं. इन द ओवर एक्साइटमेंट वी कुड डू द क्वेश्चन राइट क्वेश्चन एज एन रॉन्ग. और कई बार ऐसा होता है कि क्वेश्चन बहुत टफ लग रहा होता है सिर्फ पढ़ने से, एंड वी फील डिप्रेस्ड, ये क्वेश्चन तो मुझसे होगा ही नहीं, बट द सेम क्वेश्चन कैन बी वेरी इजी. तो दिस इज द एग्जांपल ऑफ द वेरी फर्स्ट क्वेश्चन जो हमने आज किया था. मींस दिस इन दिस वन, दिस इज द एग्जांपल. वी आर हैविंग दिस क्वेश्चन जो ऐसा लगने में लगता है कि कौन दिया है. देयर आर so many language we are having, but by the help of the cost divergence theorem we can solve the question very easily. Okay, so these are the questions from my side. Stay tuned to our YouTube channel. More and more technical questions are here for you, so just don't miss any question. Okay guys, thank you. Very good Abhinav, divergence निकाल के खुश हो गया, शाबाश. तो that is very simple and very basic question. Very good. Okay guys, now so the session will be continued for the technical questions, so stay tuned here.
Hello my dear students, welcome to IMS GATE Academy. So we have questions of strength of material. So this is one of the question which is asked in your examination. Question says that there is one cylindrical bar of length L and area A. Length of the bar is given as 5 meter and area is given as 10 meter square. Then the density of the material is given as 2700 kg per meter cube. E is 70 gigapascal, G is 9.8 meter per second square. The state of axial tension due to the self weight is there. There is no load over this bar is hanging, and under the action of its self weight, this bar will going to undergo elongation. Now in the question it is asked that you need to calculate the elastic strain energy stored in the bar. You need to calculate the elastic strain energy stored in the bar. My dear students, if any load would have been there in the bar, we could have directly calculated the strain energy as U is equals to half P into delta, right? So this is the expression for calculating the strain energy when your load P is constant. But here your load P is varying because at different section you have different amount of material hanging, and due to this different amount of material hanging in the bar, the value of load P will going to vary, right? So for solving this question, I'll assume one section at a distance of x from the bottom. The length of this section is dx, the width of this section is dx, right? I would like to calculate the elongation for this dx. So this delta can be written as half p into dx upon AE, right? So this P can be written as, this P is nothing but the load of this bar which is hanging. This is P. The weight of the bar which is hanging is P. So P can be written as rho A into X. This is the value of P, the weight of the bar which is hanging. So this is not rho, this is gamma W A into X. This gamma W can be written as rho into G. So this is rho into G into A into X. So this is the value of P, and this is changing for different depth value of X, right? So just substitute. So you have half P square dx upon AE. So this P square can be written as half into, can be written as rho G A into X into dx upon AE, the whole square, right? When you solve this, this is the total initial bit amount of strain energy that you will going to get. We need to integrate this strain energy from 0 to L in order to get the full value of strain energy U, right? So from here we get the value of U as U is equals to, it comes out to be gamma square A into x square dx upon 2E, and we need to integrate it from 0 to L, right? On integrating this, we will find that it is gamma square A into x cube divided by 6E, right? On substituting the values of all the parameters, we can easily calculate the strain energy, right? So let me substitute the value of parameter. So gamma can be written as rho into G, the whole square, into A into x cube, or I will write this as L cube. So this will be L cube. On integrating, this will be L cube divided by 6 into E, right? On substituting the values, so the rho is given as 2700, G is 9.8. So this is whole square multiplied by A is given as 10, length is given as 5 meters, divided by 6 into E. So 6 into the value of E is given as 70 gigapascal. So this is 70 into 10 raised to power 9, right? When you solve this entire thing, you will get the value of strain energy as, the value of strain energy comes out to be 2.083. Let me check. This is 2.083 joule. So this is your final answer. This is the amount of strain energy that will be stored in the elastic form for a bar which is hanging under its self weight. This question seems to be easy, but you need to analyze this question on the basis of this load which is there, and this load will be coming due to the amount of weight which is hanging below the section, right? At different values of this x, the amount of weight which is hanging in the sections, this will going to vary, hence this will going to change the amount of strain energy, right? So this is how you need to deal with this question. This was a numerical answer type question asked for 2 marks, right? Next, moving on with this, we have one more question. In this question, it is given that there are 2 bars P and Q. The temperature of the bar is increased by delta T. The temperature of both the bars is increased by delta T. Now, for bar Q, E of Q is equal to twice of E of P. Next is your alpha of Q is twice of alpha of P. This is coefficient of linear expansion for the bar P is less than that of bar Q. So with the increase in temperature, bar Q which have more value of alpha, this will going to have more tendency to move, correct, with less increase in temperature. With same increase in temperature, out of P and Q, Q has the more tendency to move, right? Similarly, for bar P, the value of E is also less. Young's modulus tells us about the strength possessing by a material. So one thing is clear, 4 options are there for the question, in which 2 options are whether the interface will shift towards right or towards left. On increasing the temperature, the bar which is having more value of alpha will going to shift more. Second is also the bar Q is having more strength, having more value of E, therefore this bar Q will going to shift more with comparison to this bar P, right? There are 2 methods for dealing with this question. Either you can calculate the value of sigma 1 and sigma 2, then calculate the individual elongation of both the bars, or you can just quickly answer this by observing the data given to you, right? In the question, it is expected from you that from the data which is there, you can analyze this question properly, right? So for this question, if you observe these 2 data, from these 2 data, one thing is clear, that bar Q has more tendency to expand with more strength, right? If I have a person next to me which is having less strength, and if I want to expand more, I can expand easily in comparison to the person which is just there right by my side, right? So for this bar, for this arrangement, the bar Q has the tendency to shift towards P. So this interface will going to shift towards left, right? So for this, your option number C is correct. Now, in order to keep this in balance, in order to keep this in equilibrium, total compressive force in bar P should be equal to the compressive force in bar Q, should be equal to compressive force in bar Q, right? So it can be written as sigma 1A is equals to sigma 2A. The length and the cross-sectional area of both the bars are given as same. So this A and A cancels out. So you have sigma 1 equals to sigma 2. So option number A and option number C are correct for this question. Hopefully you have correctly solved this question. This is one of the easiest question which can fetch you marks in just no time, right? So this is the second question for strength of material. This is second question for strength of material. Moving towards the next question for the strength of material. So the next question says that a beam of length L is loaded uniformly. This is one beam. So this is again a question of SOM. One beam is given to us like this. So this is a question of 3-dimensional loading, right? So you need to analyze this bar, just keeping in check about all the loading conditions. Then only you can analyze this bar, right? Observe this bar very carefully. Question says that a bar of length L is given to us. The length of the bar is L. It is given to us. The length of the bar is L. Next, loaded by a uniformly distributed load on the vertical plane. So you have this loading on the vertical plane. I guess we have all dealt with this type of question. For this type of question, we have one cantilever bar like this. We have one cantilever beam like this, and over which UDL is there, right? Now, first of all, tell me if this is my cross section, right? If this is my cross section. So this will be my YY axis. This longitudinal axis is the XX axis. This is XX axis. And the axis which is coming out of the plane is my ZZ axis. This is my ZZ axis. This is my ZZ axis. And this ZZ axis is coming out of the plane. It is coming out of the plane. due to this UDL which is there in the cantilever beam, there will be bending about that ZZ axis, right? There will be bending about that ZZ axis. So bending about ZZ axis, bending about ZZ axis is denoted by My. Please keep a check. Denote bending about this ZZ axis or bending moment about the ZZ axis is denoted by My. So for drawing the BMD for this cantilever beam subjected to the UDL, it is a very simple thing. So this will be like this, right? So this will be the BMD, this will be parabolic, this will be parabolic, this will be parabolic, because at any section XX, if you consider the bending moment at any section XX, if you consider the bending moment, so bending moment at any section XX will be equal to Wx square by 2. So this is the equation of bending moment at any section XX. So this is your diagram for My. This is your diagram for My, right? Now this is your diagram for My, which is parabolic. So this is the first loading condition given to you. Simultaneously for this question, one more loading condition is there. One more loading condition is there, and that loading condition is one point load is acting like this in the horizontal plane. One point load is acting like this in the horizontal plane, right? If I consider this point, and if I apply a point load at this cantilever beam, there will be deflection like this, right? So if I just draw the if I draw for suppose this is the cantilever beam, if I draw a point load like this, there will be deflection like this, right? I have just considered the example of vertical loading. Same will be happening when you apply load in the horizontal plane. There will be horizontal buckling, and this horizontal buckling is about YY axis, right? So horizontal buckling about YY axis will be there due to the point load, due to which the bending moment diagram will be, your bending moment diagram will be something like this. Your bending moment diagram will be triangular like this, right? Your bending moment diagram will be triangular like this. So this is your bending moment diagram, and this will be linear. This will be linear, right? So for this question, this is your bending moment about YY axis. So bending moment about YY axis is bending moment about YY axis is given as mz, right? So your My is parabolic, and your mz is linear. So for this question, the option which is there, in which you have this possibility, this is your My, which is parabolic, this is your My, and you have this value of mz, and this is linear. This is your mz. So this option is correct. This option is correct. This option is correct for this question, right? You can correctly mark this. I hope you have done the solution correctly. So this is the next question for Som. Moving on with this. Next we have, in the question it is given that, again we have a question of Som. So it is given that true stress versus true strain is equals to sigma is equals to 400 epsilon raised to the power 0.3 megapascal. So this is the relation between true stress and true strain given to us. Further question says that engineering ultimate strength value ultimate tensile strength value in megapascal is, right? True stress and true strain is given to us, and the relation for true stress and true strain is epsilon. Sigma is equals to 400 epsilon raised to the power 0.3 megapascal. Engineering ultimate tensile strength value is asked to us, right? So at the ultimate tensile strength point, if this is my stress strain curve like this, right? This is my ultimate tensile strength point. For this ultimate tensile strength point, the coefficient of strain hardening N is equals to epsilon. The coefficient of strain hardening N is equals to epsilon. And if you clearly observe this relation says that sigma is equals to 400 epsilon raised to the power 0.3. This 0.3 is nothing but the coefficient of strain hardening N. At the ultimate strength point, N is equals to epsilon. N is equals to epsilon, right? So you have to just substitute the value of epsilon as 0.3. So sigma is equals to, so engineering ultimate tensile strength is equals to 400 into 0.3 raised to the power 0.3. This is the simple question. This is your tensile strength. This is your strength. This is your strength. So this is again one of the easiest question. You can just calculate this. You will get the final answer as 278.74 megapascal. 278.74 megapascal. So this is the correct answer for this. The only catch here is you need to remember this. At the ultimate strength point, your coefficient of strain hardening N is equals to your epsilon E, right? So this is the question. Moving on to the next question. Next question says that, next question of Som says that the principal stresses at the point, I'll just write this, principal stresses at a point, principal stresses at a point P in a, the principal stresses at a point P are 70 megapascal, minus 70 megapascal and 0. The SYT of the material is, the SYT of the material is 100 megapascal. The SYT of the material is 100 megapascal. Then which prediction about the material failure at P is or are correct? Then which prediction about material failure at P is or are correct? So this is the question. This is a multiple select question. This is a multiple select question where more than one option is correct, right? So option A says that maximum normal stress theory predicts material does not fail. So I just write maximum normal stress theory predicts material does not fail. Material does not fail. Option B says that MSST predicts material does not fail. Then option C is your maximum normal stress theory predicts material to fail, and option D is your MSST predicts material to be fail, right? So these kind of 4 options are there. So out of these principal stresses which are there, I can clearly write sigma 1 is equals to 70 megapascal, sigma 2 is equals to minus 70 megapascal, and SYT is equals to 100 megapascal, and your sigma 3 is equals to 0, right? So this is the data given. So according to maximum normal stress theory, 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 right? According to maximum normal stress theory, your sigma maximum should be less than SYT. Your sigma maximum should be less than SYT, right? So here my sigma maximum is 70 megapascal and SYT is 100 megapascal. So 70 megapascal is less than 100 megapascal. Hence I can say that the material is safe according to maximum normal stress theory. According to maximum normal stress theory, the material is safe. So maximum normal stress theory predicts that the material does not fail. Now talking about MSST, now talking about MSST, according to MSST, sigma 1 minus sigma 2 should be SYT by N, right? It be SYT by N, where N is the factor of safety for this, right? So I can just write down, in order to compare sigma 1 and sigma 2. So this is 70 minus of minus 70 is equal to 100 by N, right? Is equal to 100 by N. I need to just compare what should be the value. So this sigma 1 minus sigma 2 should be less than SYT by N, right? So from here I can clearly get the value of N as 100 by 140. From here the value of N is less than 1. Hence the material fails according to MSST theory. According to MSST theory, the material will going to fail. The material will going to fail, right? So for this question, your option number A and option number C are correct. For this question, option number A and option number C are correct. So this is one of the easiest question. Probably you have correctly marked the correct answer for this. Okay, so this is the question from Som. Moving on to the next question of Som. The next question of Som was easy, very easy, right? It says that there is one cylinder which is hanging like this. There is one cylinder which is hanging like this. There is one cylinder which is hanging like this, right? There is one cylinder which is hanging like this, okay? And in this cylinder there is some water filled. There is some water filled like this. So this is a thin cylinder which is hanging like this, and on this thin cylinder your water is filled. You need to check on the value of longitudinal and circumferential stresses. So sigma 1 is your longitudinal stress. So sigma 1 is equals to longitudinal stress. This is your longitudinal stress, and your sigma 2 is equals to sigma C is equals to circumferential stress. Is your circumferential stress. Regarding these two, some options are given. So option number A says that the variation of sigma 1 and sigma 2 is like this. So this is the variation of sigma 1 and sigma 2. So this is sigma 2, this is sigma 1. So this is option number A. This variation is of stress versus height. All the plots are for stress versus height, right? So this is option number A. Option number B says that your stress variation is like this. So this is your sigma 2 and this is your sigma 1. So this is your option number B. Option number C says that your sigma 2 is varying like this, but your sigma 1 is constant. This is your option C. Option D says that your sigma 1 is varying and sigma 2 is constant. Right? So these are the 4 different options given to us and we need to find the correct solution for this, right? So this is a very easy question. If you observe this question, I have said it many times to my students. It is very important to read the question properly. Read it twice, read it thrice before attempting to the solution for the particular question. Read the question properly, because reading the question properly will going to solve your question halfway through. You need not to worry about that, right? Now this question is so simple. Just observe this cylinder, okay? Just observe this cylinder. If I write the expression for, if I write the value expression for sigma L, it is 4 PD, it is 4 PD, it is equal to PD upon 40, sorry, it is equal to PD upon 40. It is equal to PD upon 40, right? And sigma C is equals to PD upon 2T. For this condition, this expression of longitudinal stresses is not valid, but this expression for circumferential stress is valid. Now understand this, this P at any section, this P at any height, this P at any height, this P at any height is due to the weight of water which is there below it. This P at any height is due to the weight of water which is below it, right? So this P is varying with respect to height. This P is varying with respect to height. This P is varying with respect to height. So your circumferential stress will going to vary with respect to height, right? So if I check all these two options, in both the options the circumferential stress sigma 2 is varying. On checking further, here in option C the sigma 2 is again varying, right? But option number D is out of the box because there sigma 2 is constant. Sigma 2 will be varying, sigma 2 is varying with height, because P is varying with height, Now talking about the longitudinal stress, this longitudinal stress sigma L, this will be due to this entire weight of water which is there. This sigma L will be due to the entire weight of water which is there. This sigma L will be due to this entire weight of water. And you travel anywhere, this sigma L will remain constant because weight of the water is constant. This sigma L is due to this entire weight of water, no matter you are standing at whatever sections. So this sigma L or sigma 1, this is constant with respect to the height, right? So for this question, your sigma 1 is constant, with height. With height, right? It is not varying with height. So for this question, option number C is the correct answer. I hope you have marked the correct answer for this. Sir, if only one right option selected instead of two, then also my dear Yashpal, you won't get any marks. There is no negative marking, but still you won't be getting any marks if you haven't selected all the answers for a multiple select type question, right? So this is the only drawback with multiple select type question, okay? So these are the questions which are there for strength of material. We will continue with the solution. Just be there with the channel. Okay. I hope you have seen all these questions. So if I talk about all these questions, if I talk about all these questions, right, you will find that multiple select question and numerical answer type question. Almost 35 questions are there without negative marking. But just imagine the students which have cracked this amount of questions, how much they have secured in this examination. I have kept telling my students, go for these type of questions for getting good rank. This multiple select question and numerical answer type question will going to decide how much good rank you are getting. Your gate qualification is ensured by multiple choice question. If you answer these multiple choice question, you can simply qualify gate, but getting good rank, you need to crack these questions. These are simple, easy questions. The only thing is, you need to read the question properly. So my next faculty will continue with the solution. Okay, welcome sir.
Yeah, hello everyone. I hope your GATE exam is good. Now, I am here with the solution of fluid mechanics, right? So, just let me know in the chat box how many questions from the fluid mechanics you have solved. Yes. Yeah, hello my dear students. So, your first question which we got is from this fluid kinematics, right? So from fluid kinematics, we are having one question, and what this question says, the water, fluid is given as water, so density of water is given to us, that is 10 to the power 3 kg per meter cube, right? Also, the velocity vector, it is given to us as k xi plus yj meter per second. Also, k value is given to us. This k value is what? This k value is given as 2 second inverse, right? Also, it is given as the pressure value at point A, and the coordinate of this point A are 0, 0, and it is given as 100 kilopascal. Right? Now, in this question, it is asked to calculate the pressure value at the coordinate 2, 2. At 2, 2, right? And you need to find out the value in kilopascal only. So note down the unit, you need to find out this in kilopascal only, right? So if we talk about this particular velocity vector, right? So let's suppose if I take this as a Cartesian coordinate, right? So this is my x, this is my y. I am taking this point as A, which is at 0, 0, right? And point B, as it is the two-dimensional flow condition only given to us, and this point is your B at 2, 2. At 2, 2, right? Now we need to find out the pressure value. Which particular equation we can apply here? Tell me. We know that for the calculation of pressure, we can use any momentum equation, right? Or we can also use this Bernoulli's equation. But the main condition for Bernoulli's equation is what? If these points are lying on a different streamline, then your flow should be what? Your flow should be irrotational, right? So to check the irrotationality of flow, what I can do? We can check it directly from the vorticity, right? So if I calculate the vorticity, we know that for the calculation of rotationality, we have either angular velocity, we can check it from the vorticity, we can also check it from circulation, right? So directly we can see it will be what? In z direction I need to find out, so it will be del v by del x minus del u upon del y, right? Del v by del x, this is the particular v value, so u value is your x, v value is your y, right? Or you can say x into k, y into k. Now this k is constant. If I take the derivative of v with respect to x, it will give me value 0. Derivative of u with respect to y, again we are getting it 0. It means vorticity is what? Vorticity is 0. If vorticity we are getting it as 0, can I say that this is irrotational flow? Can I say that this is irrotational flow? Now, if this flow is irrotational, now we can apply directly the Bernoulli's equation to it, right? Now I am applying the Bernoulli's equation at section A and this point B, right? So at point A and point B we can apply the Bernoulli's equation. Now if I apply the Bernoulli's equation, I can write Pa by rho g plus Va square by 2g plus the datum at A, or datum head at A, it will be equal to Pb by rho g plus Vb square by 2g plus Zb, right? Now try to see, if I assume my datum to be at this point, at this level, can I say that Za will be 0 and Zb will be equal to 2 and Zb will be equal to what? Zb is equal to 2, right? Also, for this particular value, to use this particular value, I will need this velocity at A and velocity at point B. So how we can calculate the magnitude of velocity? We can calculate the magnitude of velocity as velocity in x direction. Let's say this is our u value, so u square plus v square. We need the value of v square only, right? So I will directly write it as v square value. So it will be what? It will be your u square plus v square, right? Now first I need to calculate it for A. So velocity at point A, it will be what? What is the u value? U value is equal to k into x. X value, it is 0 for point A, y value 0 for point A, right? It means u value is 0, v value is 0. So it means velocity at A is equal to 0. What about velocity at point B? So velocity at point B, again k is equal to 2 and this particular value. So 2 into 2 square plus 2 into 2 square. Clear? This is 16 plus 16, that is 32 meter per second. Now we have VA value, we have VB value. Clear? Now we can put this particular values in this particular equation, right? So Pa by rho g, Pa value, I know the pressure value at A, that is 100, and this 100 is given in kilopascal, right? Divided by rho, density of water, 10 to the power 3 into g. Let's take it g only for this particular time, as it will get cancelled out in later stages. Velocity at A, it is 0 plus Za value is also 0. It will be equal to Pb. Pb value is, we need to calculate by rho 10 to the power 3 into g plus Vb square, we have calculated it as 32. This is the square value, right? Vb square value directly we have calculated. So 32 divided by 2 into g, and Zv value is our 2. Zv value is our 2. Clear? Now if I multiply the total equation with g, so this g will be cancelled out, this g cancel out, this g cancel out, right? And this particular value, it is multiplied with g now. This 2 we will get it as particular value 16, right? So 16 plus, if I take this G to be equal to 10, this particular value will be 20. So 20 plus 16, 20 plus 16, that is our 34 value, right? So from here, if I calculate this PB value, this will be 100 minus 36, that is your 64 kilopascal value. That is your 64 kilopascal value. Just let me know in the chat box if you got the same answer or not, right? So this is the question from your fluid kinematics. Second question, which is asked from this fluid mechanics, it is related to the boundary layer condition. Clear? So second question, it is from the boundary layer. So one question is from boundary layer. What this question says, the density of air was given to you as 1.2 kg per meter cube. Also, kinematic viscosity is given as 1.5 into 10 to the power minus 5 meter square per second. Free velocity it is given as 2 meter per second. Clear? Now it is asked that there is a flat plate, right? Now from this edge distance, at a distance of 15 mm, the shear at boundary, it is given as, so shear at boundary corresponding to this 15 mm, it was given as TW, right? It was given as TW, and it is asked that what will be the shear at boundary from this particular leading edge at a distance of 30 mm. Right? Now, for this question, first we have to check if the flow is laminar or if the flow is turbulent over this flat plate, right? For this particular x value. So we know that, how we can check this? We know that Reynolds number at x, it is given as u infinity into x, or free velocity into x divided by nu, right? What is the free velocity given? This is the 2 meter per second. X value, it will be our 0.015 meter, and nu value is what? 1.5 into 10 to the power minus 5. Now if you put this particular value for x is equal to 15 mm or for x is equal to 30 mm, in both the cases it is coming less than your 5 into 10 to the power 5 value. That is nothing but Reynolds number for this critical case. It means if this particular Reynolds value, it is coming to be less than Reynolds number at this particular critical condition, what we can say that the flow at both the cases, it will be what? It will be laminar. It will be laminar. Yes or no? Now, if the flow is laminar, we have asked that what will be the tau b corresponding to this 30 mm, right? It means we need the relation between this tau value and this x value, right? How we can get this? We know that for laminar boundary layer, what is the relation? We know that delta by x, it will be equal to 5 upon under root of Reynolds number to the power x, right? Also we know that local skin friction, that is your CF value, and it is 0.664 upon under root of Reynolds number to the power, Reynolds number corresponding to this particular x distance. Yes or no? Right. Now also we know that this local skin friction coefficient CF value, it is related to boundary shear at any distance x divided by half rho into u square. Clear? So from here what we can conclude, how this particular tau value and this particular x value are related. So can we say that the boundary layer, the boundary shear at any distance x, it is inversely proportional to this x value. It is inversely proportional to this x value, right? Now we need to calculate this boundary shear, at x is equal to 30 mm, right? So we can write it as boundary shear at x is equal to 15 mm. This value will be equal to what? This will be equal to under root of 15 by 30, that is nothing but 1 by root 2, right? So it was asked this particular tau naught or boundary shear at x is equal to 30 mm in the terms of this TW. So can I say that this tau value at x is equal to 30, it is equal to 1 by root 2 of this TW value, right? I hope you got this particular answer in the exam. Clear? Now there is one more question from your fluid static, right? So we have seen one question from fluid kinematics, one question we have seen from this particular boundary layer. There is one question from your hydrostatic force calculation. Clear? So what this question says, in the question it was given to you that there is a particular wall, right? So one wall was given to you. This is hinge at this particular point. Let's suppose this point is O. Now there are multiple fluids. So one fluid is given to you as up to 1 meter. There is a fluid with density is equal to 1000 kg per meter cube, and for this next length, that is 2 meter, the density given as, so let's suppose this is density 1, this is density 2. Density 2 is given as 2000 kg per meter cube, right? Now it was asked to calculate the moment value at this particular point. So you need to calculate what will be the moment at this particular point. Clear? Now we know that due to this particular fluid, there will be a pressure on this particular wall, right? And due to that pressure, there will be a hydrostatic force which is acting on this. Clear? Also due to this particular fluid, there will be one force which is acting on this particular plate, right? Clear? Now students, if you have attended the last session which was taken by Pragya sir, so they have discussed the same question in yesterday class only, when Pragya sir was taking this particular quick revision session. So the same question they have discussed in that class. If you were there, you might have done this particular question correctly in the exam, right? Now, how we can attempt this particular question? How we can attempt this particular question? We know that the pressure due to this particular fluid on this wall, we can calculate this pressure force by drawing the pressure distribution diagram, right? So this will be your triangular distribution. So here pressure value is 0. Let's suppose here pressure value is P1. What will be this P1 value? This P1 value will be equal to rho 1 into G into this particular value. Let's suppose this is Y1 value, right? And due to this particular fluid, if we need to calculate the pressure force, it will be what? Now the slope will be different as this density is different, right? As the density is different. Now what will be this particular value? It will be equal to P1 plus this particular rho 2 into G into Y2. If we take this 2 value as Y2 value, yes or no, right? Now just we need to calculate this P1 value and this P2 value. So if I calculate this pressure value, this P1 value, density is 1000 given to you, into G is 9.81, height is 1. Now this will be in Pascal. Let's suppose take this particular value in kilopascal. So this will be your 9.81 kilopascal, right? If I calculate this P2 value, so what will be P2 value? P2 value will be equal to P1 9.81 plus what is the density? Second density is 2000 into 9.81 into 2, again 10 to the power minus 3. So this particular value P2 value, if I calculate this P2 value, we are getting it as 49.05 kilopascal, right? So this particular value is 49.05 and this value, it is your 9.81 kilopascal. Clear? So this is one pressure value, this is second pressure value. How we can calculate the force? 17.2 kilonewton meter per meter. Yeah, we are taking this particular length to be meter, right? Now try to understand how we can calculate the force value per unit length. How we can calculate this force value per unit length? The force value per unit length will be what? Or per unit this particular width, right? This particular dimension we are taking it as 1 unit. This one given to calculate for the per unit width, right? This particular value. Now if we calculate this particular value, now we need to find out the area of this particular distribution diagram, right? First, if I calculate this pressure distribution diagram, due to this particular fluid, there will be a force acting, let's say F1, and it is acting at a distance of Z1 from this particular point O, right? Also there will be one pressure force which is acting due to the second fluid. Let's suppose its value is F2. Let's suppose this value is F2 and it will act at the CG of this particular trapezoid, right? So let's say this particular value is what? Z2. Now how I can calculate this F1? Area of this triangular part. This particular height is what? 1 meter. What is this particular base? Base we have calculated 9.81, right? So I can calculate this F1 value as half base value, that is 9.81, and height is given as 1. So it is 9.81 divided by 1, that is your 4.905 kilonewton. This force will be for per meter, right? For per meter length or per meter of the width inside this particular board. What will be Z1 value? We know that this particular force F1, it is acting at the CG of this particular triangle, right? If it is acting at the center of this particular triangle, I have to take the moment of this force about this point O. What will be its distance from here? So from here it is acting at, this is particularly y1 value. So can I say that this will be y1 by 3? y1 is your 1 meter by 3. Can I say that this is approximately 0.33? This particular value is 2. So it will be 2.33. Clear? Yeah, hi Suraj. So it will be what? 2.33 meter. Second thing is I need to calculate this F2 value. F2 value will be area of this trapezoidal portion, right? So what will be the trapezoidal portion area? Half sum of parallel sides. These are the parallel sides. One parallel side distance is 49.05. Second is 9.81, right? 9.81. So 9.81 plus 49.05. And what is the distance between these parallel sides? That is 2. That is 2. So how much value you are getting? It is 49.05 plus 9.81. Can I say this is equal to 58.86 kilonewton per meter, right? And it is acting at which point? It is acting at a distance of Z2 from point O, right? How to calculate the CG of this particular point from here? This is your P1 value, this is your P2 value, right? So it is like this. This is the trapezoid. So this is your P1, this is your P2, this is your Z2 value, right? So what will be Z2 value? Z2 value will be your P2 plus 2 times of this P1 plus P2 plus P1 into this total distance is what? This total distance is y2, which is nothing but equal to 2, right? So y2 by 3, right? y2 by 3. Now if I put the values, in this particular formula, what I am going to get? This is your P2 value. So P2 value was our P2 value. It is our 49.05. So 49.05 plus 2 times of P1. P1 we have calculated it as 9.81 divided by 49.05 plus 9.81 into 2 by 3. Clear? This value you are getting it as 0.77 meter. Now we have force value. We have the lever arm of this particular force from this point O, right? We can calculate the moment value. So what will be the moment value? So the moment about point O, can I say that it will be equal to F1 into Z1 plus F2 into Z2, right? So what is the F1 value? F1 value, that is our 4.095, 4.905, right? 4.905 into Z1 value, how much? We have calculated it as 2.33 plus F2 value we have calculated it as 58.86 and it is acting at 0.77. So 58.86 acting at 0.77. If you calculate this particular value, so this particular value you are going to get at 57.34. 57.34, that is kilonewton meter. This is acting for this particular value, right? This is acting at this particular point. I hope you got the same solution for this particular question, right? And again, you can check this particular question, the same type of question. It was discussed yesterday only by our senior faculty Pragya sir when they were discussing about the concept related to your fluid mechanics, right? Yesterday only they have taken the session for you guys, the quick revision session in which our faculty has discussed about this type of problem. Clear? Now to discuss the questions of other subjects, I would like to invite the other faculties, right? Okay. Let me know if you got the same solution for this fluid mechanics or not. Just let me know. Have you got the same solution for this? Just comment. Let me know in the comment box, right? So our team, it is dedicated to provide you the best solution, the error-free solutions, right? So this one is the question from your fluid static part, right? So almost the examiner has touched all the parts of fluid mechanics. Clear? Now I would like to invite Vijay sir for the further questions.
Hello students. So here I am come up with the manufacturing question. Have a look on this. Slides are over or what? Right, here I come up with the manufacturing question solutions. Now let me read question from material science, guys. A steel plate with carbon weight percentage of 1.5% of carbon, no other alloying element. So that means here the carbon of the steel plate is having carbon percentage of 1.5. It is completely a plain carbon steel because no alloying element is there. It cools slowly just below the eutectoid temperature as a part of iron carbon equilibrium diagram shown in the figure. Find the ratio of pro-eutectoid cementite to the total cementite content in the microstructure that developed below the just below the eutectoid temperature. Okay, so here what we have to find, guys, a steel plate is given. A steel plate which is having carbon percentage of 1.5%, weight percentage given. All right. Now here what we need to find, it is cooled slowly from eutectoid temperature, and we have to find that ratio of pro-eutectoid cementite, that means Fe3C divided by total cementite, that is Fe3C. Okay, so this is what we have to find. So this is a ratio they ask you to find out. For that they gave you one diagram also, guys. So now let me draw a simple diagram for this. Right. Right. So a small part of iron carbon equilibrium diagram is given. It is not complete diagram, guys. It is not complete diagram. It's just a part of a small part of iron carbon equilibrium diagram, and as you know that it is a 723 degrees, or some textbook it is given 727 also, not a problem, 723 degrees centigrade. And so the carbon percentage here is 0.76 dimension, and here the carbon percentage is given 0.022 percentage of carbon. So in this axis it is percentage of carbon, in this axis it is a temperature, as you know that already, right? Now here you need to understand that where exactly eutectoid reaction is going to be takes place. So there are three reactions: peritectic reaction, eutectic reaction, and eutectoid reaction. So here eutectoid reaction, I said that at 0.8% carbon, 723 degrees centigrade, austenite is completely converted into perlite. That reaction we are calling it as a eutectide reaction. So where exactly that is? Here, as per the given data, the eutectide reaction takes place here. And what is the carbon percentage here? 0.76 given in the problem, but it is actually 0.8. So 0.76% of carbon and 723 degrees centigrade austenite is completely transferred into perlite. So now here it is a austenite plus ferrite, and it is completely ferrite, right? Now here at eutectide reaction, what happened? It is completely 100% perlite. It is 100% perlite. Yes guys, it is 100% perlite. Now, if you decrease the carbon percentage below eutectide reaction, then what happen na? Ferrite is going to be formed, right? If you add carbon percentage, that means if you increase the carbon percentage in the steel, then in place of ferrite, cementite is going to be formed, isn't it? This is what we have discussed. But at exactly 0.8% carbon or 0.76% carbon, completely austenite is converted into perlite. Now, so if you go for below 0.8% carbon, ferrite is going to be formed, right? Ferrite is going to be increased. Now, if you come 0.8% carbon, then what happen? Cementite is going to be happen. Now, here one particular steel is given, which is carbon percentage of 1.5. Now let us see that it is 0.8. Somewhere our steel is here. Somewhere our steel is here, right? This is a 1.5% of carbon. Now here you need to understand one thing, guys. Suppose at this point, what is the structure of steel? What is the structure of steel? It is completely austenite structure. It is completely austenite structure. That means it is a single phase. Completely austenite structure. Austenite is only there up this point. Whenever it cross this line, that means it is the upper critical temperature of cementite, na? So we call it as a ACM. Whenever it cross ACM, then what happen, na? See, at the grain boundaries of austenite, cementite is going to be formed. At the grain boundaries of austenite, cementite is going to be formed. Now let me show you. Right. So here it is austenite structure, austenite structure, austenite structure, austenite structure. Now at the grain boundaries of austenite, cementite is going to be formed. Cementite is going to be formed like this. Okay. Now if you keep on cooling slowly, then what happen na? The formation of cementite is going to be increased. The formation of cementite is going to be increased. Fe3C is going to be increased up to here. So whenever it cross this eutectide line, then what happen na? All the austenite is going to be transferred to, all the austenite is going to be converted into perlite. All the austenite is going to be converted into perlite, and whatever the cementite is formed, that remains same. That means this is your cementite. This remains same. Right. So whichever the cementite formed just below the upper critical temperature, and it reaches to maximum up to this temperature, right? Now this formation, whichever is formed earlier, that we call it as a pro-eutectide cementite. Got it, guys? So you need to understand that what is pro-eutectide cementite, what is total cementite, then only it is possible to solve this question, right? So whichever the thing is, during the cooling from upper critical temperature to eutectide temperature, how much amount of the cementite is formed, that remains same. That is called pro-eutectide cementite. Got it? So here, after reaching this point, pro-eutectide cement remains same, and all the austenite is converted into perlite structure. So here it is your Fe3C. This remains same. So how much amount of the pro-eutectide cement is formed in this region, that remains same, and the rest of the austenite is going to be converted into perlite. Got it? But here he didn't ask that perlite percentage. He asked that cementite, pro-eutectide cementite. They asked for calculating amount of cementite and amount of perlite, we have a lever rule. Got it? So where exactly we have to find? In between the see, if you go this side, it is a 100% cementite at 6.67% of carbon, isn't it, guys? Right? Now here this is your tie line. You have to take tie line this, that is at the 0.8% carbon. Now let me go for C. Let us calculate that projectile cementite. Now I am taking one tie line. So here the tie line 0.76% of carbon, and here it is a 100% perlite. Here it is 100% perlite, and here at 1.5 degrees, 1% of carbon, we have to find projectile. At 6.67% of carbon, okay, 100% cementite is there. Okay, as you know that I have highlighted one point during our classes, guys. What is that? What is that? What is that? So the lever rule can be applied in between the two pure phases only. Okay, if you go back that at exactly 0.76% of carbon, you will get 100% perlite. At 6.67% of carbon, you will get 100% cementite. Right? In between the pure phases only, you can apply lever rule. But in between that, how much amount of the perlite, how much amount of the cementite is formed, that you can easily find out by using the lever rule. Okay, got it? Right. Now let us go away. So by lever rule, let me change my ink. By lever rule, got it? By lever rule, what percentage we need to find out? Projectile cementite. That is why what I said. So whichever you require, that is opposite arm length divided by total arm length. Okay. Now by lever rule, projectile Fe3C is equal to opposite arm length. So this side your cementite, this side your perlite, but you require this percentage. That is why opposite arm length. What is that opposite arm length? 1.5 minus 0.76 is divided by total length. That is total length is 6.67 minus 0.76. Got it, guys? Now if you solve that, then you are going to get, it is 0.126. 0.126. Okay. However, if you multiply with the 100, so that you will get 12.6. That is not required, because here you have to find that projectile Fe3C divided by total Fe3C. By using this tie line, we had find that projectile Fe3C. Now we have to fight for total cementite. So total cementite. Right. For that total cementite, where we are supposed to take our tie line, that is the task. Okay. Now listen carefully, guys. Right. So now my tie line is here. See, this is what my tie line. Okay. Now here 100% ferrite, here 100% ferrite, here 100% cementite. Now I can get a total cementite. Right. Let me take my tie line. This is 0.022% of carbon, and here ferrite is 100%. Okay, alpha means ferrite. Now here our tie line is 1.5% of carbon. Now here 6.67% of carbon, and here 100% Fe3C. Now here if I want to total my cementite, so we can also calculate individual ferrite also, but it is not required for this problem. Okay, so right now let me write that. Total cementite, total Fe3C is equal to, now how can I write that? It is a opposite arm length again. If I want cementite, I need to take this tie line. If I want ferrite, I need to take this tie line. Got it? Okay, right. Fe3C, that is what, here 6.67 minus 0.0222 divided by, it is again 6.67. Oh my god. Sorry guys, little, right. See guys, here 6.67, no 1.5, opposite arm length na, 1.5 minus 0.022 is divided by 6.67 minus 0.022. So that if you solve this, then you are going to get it is 0.222. Now your problem is not yet solved. If suppose if I want alpha, then if I want alpha is equal to, then it is opposite arm length, that is 6.67 minus 1.5 is divided by 6.67 minus 0.022. So we can also calculate individually, but here we require only total ferrite and eutectile ferrite, isn't it guys? Total ferrite and eutectile ferrite. That is the reason why here we got that. So this is a total ferrite 0.22 and your pro-eutectile ferrite 0.126, right? Now let me go for, if I substitute here, 0.126 is divided by 0.22, then you are going to get it is approximately 0.56. This is your, oh my god, 0.56. Yes guys, this is your final answer. Okay, the ratio of pro-eutectide ferrite, pro-eutectide cementite to pro-eutectide pro-eutectide cementite to total cementite is equal to this much. Now here, in order to solve this kind of question, you need to know that reactions as well as the lever rule. Okay, now lever rule, I said that lever rule can be applied in between the two pure phases only. Got it guys? Now let us go for another question. Okay, now the question is here, it is a CNC machining. In a CNC machine, stepper motor used for table movement control a transfer direction. Okay, right? What is that? CNC machine is used. CNC machine stepper motor is used to translate the table. Okay, so which is having lead screw pitch is 5 mm and the stepper motor having 50 steps. Okay, for one revolution. Now the stepper motor is directly coupled or connected into the lead screw. Then how many pulses are required in order to move the table to 100 mm? Got it guys? Right? Now here I just give you the small diagram. However, we have discussed already this. Here a stepper motor is there. Okay, stepper motor, and it is directly connected to the lead screw. And it is directly connected to the lead screw. As you know that it is a lead screw, stepper motor. This is a motor. Okay, now it is a lead screw. To the lead screw we have a work table, isn't it? It is a work table, isn't it guys? So stepper motor rotates like this and the lead screw also rotate like this. Now pitch of the lead screw is given is equal to 5 mm, and also the stepper motor have number of steps is equal to 50. That means if I want to rotate my stepper motor one complete revolution, I need to rotate 50 steps. I need to rotate 50 steps, right? Now what my point is, how many number of pulses required in order to translate the table, 100 mm. Okay, this is what the question. Okay, if I want to move the table 100 mm, how many number of pulses are required? That is what the question. Got it guys? So this kind of question, so I have already gave you many examples in our regular classes. Now here see that number of steps are given, that is 50, and pitch is given, that is 5 mm. Okay, now here find the step angle. Step angle is equal to, step angle is equal to 360 divided by 50. That is, so that you are going to get it is a 7.2 degrees. Got it? So for one complete revolution it requires 50 steps. So what is the step angle? That is what I have found. So what is your basic unit length guys? I gave you na basic length unit BLU is equal to, it is alpha P is divided by 360, isn't it? Right. Now from here if I substitute here 7.2 into pitch is 5 and divided by 360, so that I am going to get 0.1 mm. Alright, I found my BLU. Got it guys? I found my BLU. What is the meaning of BLU? What is the meaning of BLU? Basic length unit. That means for one pulse, how much amount of the work table is moved? How much amount of the work table is moved? So for one pulse, it is moving 0.1 mm, isn't it guys? Right? But how many mm we have to move? 100 mm we have to move, right? So let me write that. For one pulse, so we can move 0.1 mm as a work table, isn't it? Right? Now if I want to move 1 mm, so that I require 10 pulses. Isn't it? But I am supposed to move 100 mm. I am supposed to move 100 mm. Then how many pulses are required? Then 10 into 100 pulses. So in order to move, so that is 1000 pulses required in order to move 100 mm as a work table. Guys, you are getting my point. For one pulse, you can move the work table 0.1 mm. For if I want to move 1 mm, then I require 10 pulses. But I am supposed to move 100 mm. So 100 mm into 10 pulses into 100. So that 1000 pulses required in order to move the work table for 100 mm. Got it? So 1000 pulses required. 1000 pulses required to move work table 100 mm. To move work table 100 mm. Okay, now your answer is, guys, 1000 is your answer. Hope you understand the solution, guys. Now let us go for, thank you Prasanna Kumar. And one more question, it is also from material science. Right, it is also a material science question. Now let me read that question. Determine the theoretical density in gram per cc, right? So what? Determine the theoretical density gram per cc. Density we have to find in gram per cc, guys, okay? And what things given? So of FCC unit cell of an atom having atomic radius 0.1 nanometer, okay? Right here FCC theoretical density we have to find, which is having atomic radius of r is equal to, it is 0.1 nanometer. All right. Now from here atomic weight is also given. So atomic weight A is given, that is 60 gram per mole. All right. Next, so Avogadro's number is given, that is n is equal to 6.023 into 10 to the power of 23 atoms per mole. Atoms per mole. So this is what the given data. Yes, guys, this is what the given data. All right. Now here we have a direct formula for determining this. Density is equal to, it is number of atoms in the unit cell, and atomic weight is divided by volume of unit cell into, so Na. So that you are going to get directly density. Okay. Now see that here mass into volume, then volume into density, so that you will get mass. Now here atomic weight into number of atoms, so that mass. Okay, from there I have developed this. All right, guys. Now, so number of atoms, where n equal to number of atoms in FCC. Number of atoms in FCC, isn't it, guys? Now here how many atoms are there? 4. How 4? There are total 8 corners in the unit cell. Each corner says 1/8 atom. So that 8 corners, 1/8 atom, you will get 1 atom, right? There are 6 phases of the unit cell. 6 phases of the unit cell. 6 phases of the unit cell. Each phase half atom will be saved. Okay. Now here see that 8 corners, 1/8 atom plus 6 phases plus into here 6 phases into half atom. So that here 1 plus 3, so that you are going to get number of atoms 4. Now volume of unit cell. So if you take unit cell, volume of unit cell, right? It is a FCC structure, na? FCC structure should be like this, right? Now here this is your RA, it is the size of unit cell. Now here this will be your somewhere R. Okay. Now, so let us go for, but here in FCC structure you need to know the relation between the A and R. You need to know the relation between the A and R. So A root 2 equal to 4R. A root 2 is equal to 4R. This relation you need to remember in order to find the volume. Now let us go for calculating the volume of unit cell, that is equal to A cube. So now as we know that A root 2 is equal to 4R. From here A is equal to, it is 4R by root 2. So now let us write that here 4r by root 2, right, whole cube. This is what your volume of cube, right? Right. Now number of atoms we found, atomic weight we have already, and volume of cube we are finding, and Avogadro's number also we are having in the problem. Tejas Shekhar, Omkar Power. Ma'am, for no, 1 minute. Right now here find out the volume of this one. Now R is given, guys. R is given. How much it is? R is given. R is given 0.1 nanometer. For that, all dimensions are in mm. Na? Convert this fellow into mm. That is 0.1 into 10 to the power of 9 meters into here. I am supposed to write this square, so that it is going to be converted into centimeter. So now here I will write it is 0.1 into 10 to the power of minus 7 centimeter. So substitute here 4 into 0.1 into 10 to the power of minus 7 and is divided by root 2 whole cube. Alright. Now if I calculate my volume, I am going to get it is 2.26 into 10 to the power of minus 23 cc centimeter cube I will get. Now I got all the values. I found volume, I found the number of atoms. So for finding the volume, you need to know that in FCC structure, what is the relation between the radius and as well as the size of the unit cell. Okay. So atomic radius as well as the size of the unit cell you need to note. You need to note this relation, right? From this relation, I found that volume. I got the volume and I got the A. Now let us go for substituting the values in density. Now my density is equal to, it is number of atoms into atomic weight is divided by volume of unit cell into Avogadro's number, right? From here number of unit cell 4 and then A is 60 grams per mole. In the problem it is given A is 60 gram per mole. Alright guys, right? Now here we have found that 2.26 into 10 to the power of minus 23 into Avogadro's number is 6.023 into 10 to the power of 23, isn't it guys? Now if I solve this, then I am going to get it is 240 is divided by 13.62, so that I am going to get my density 17.6 gram per cc, right? So very careful about the units guys, okay, because here this one density asked in gram per second, that is why I have converted my radius into centimeter. Okay, so here I have converted my radius into centimeter. So unless until you are not able to not having the confidence in converting the units, so that it is not possible to solving this kind of question. Okay, hope you understand this solution guys. Okay, thank you.
Hello everyone. So till now we have discussed so many questions guys. Thank you so much the questions that you have provided, right? So now I came up with some few more numericals, okay, from theory of machine engineering mechanics and one from applied thermodynamics. Okay, Tejas, hi Prasanna, hi Suraj, hi Omkar, right? So guys, we'll discuss few more questions, and if anyone is having any doubt, you can also ask in the chat box, right? So I will start with one question from theory of machine. First of all, theory of machine question. Right. So see, theory of machine question in which they have mentioned a gear. Okay, so this is gear 1 and this is gear 2 we are having. and what they have mentioned in the question, the center distance is 30 mm, right? Frequency ratio, velocity ratio basically they have mentioned as 1/4. Okay, can you just verify the data? Everyone, please verify the data as well. Okay, just now we have received the question, and they have also mentioned the diametral pitch. Diametral pitch, which is equals to 8. Okay, which is mentioned as 8, right? So actually what they are asking, the number of teeth on gear 1 actually. Number of teeth on gear 1 they are asking. Okay everyone, see. Right, so this was the data, right everyone? So this was the data. Now we'll solve for the number of teeth on the gear 1. So center distance they have given, right, 30 mm. Okay, we'll utilize that one, and this velocity ratio is given. So now first of all understand, when we are writing center distance, it is nothing but r1 plus r2 equals to 30 mm, right? That is what given. Velocity ratio, see, velocity ratio omega 2 by omega 1 can be also written as t1 by t2, okay, equals to d1 by d2, right, equals to r1 by r2, right, like this, and this value is given as 1/4. So from this we will have a relation between r1 and r2, and we can utilize this relation with the center distance, r1 plus r2 30 mm. So from that we will get the value of r1 and r2. Yes everyone, okay. Now see, from this we will have a value r2 equals to 4r1. Now we will utilize this value. We will utilize this value in this equation number 1. This is equation number 1. So from equation 1, we will have this thing. Okay. Now see everyone. So r2 value is 4,1. If I put there, so we will have 5r1. Okay, equals to 30, and so r1 value we will have as 6. Right? R1 value is 6. Now you should understand. So when r1 value is 6, so obviously d1 value will be what? 12. Clear everyone? 12 mm. Now as the diametral pitch is given, okay, it is nothing but the t divided by diameter, right? So it is given as 8. It is given as 8. So diameter is what? 12. Okay. So for the first gear we are writing, so number of teeth on the gear 1 will be what? 8 into 8 multiplied by 12, and that will be what? 96. I hope you are getting the same answer as well. Just tell me everyone. 96, everyone got the answer 96 here? Yes or no? Right. So it was a very easy question in theory of machine, and see, the such type of questions already we have discussed in our live classes, right? Now one more question we'll discuss here from engineering mechanics. Okay, from engineering mechanics we will discuss one more question. So in the engineering mechanics question was a little bit difficult, I would say, because generally see, this type of question you will see in our physics paper like in JEE. Okay, so that is not, I would say, that much difficult, but if you know the basics you will be able to solve this question, right? So basics is what required here. Okay, now see everyone, from the engineering mechanics we are having question from engineering mechanics. See, this was the inclined plane, that is what given. Okay, this is the mass we are having, 2 kg. Okay, right? Now see everyone, what is happening here, this mass is what falling like this. Okay, now this distance they have given as 4.9 meter, right? 4.9 meter they have given. Now the collision is perfectly elastic, that is what given in the question itself. Collision is perfectly elastic. Next they have mentioned what? Okay, perfectly elastic, and what they are asking? They are asking the momentum vector, right? see what is the question here, the momentum vector, okay, momentum vector they are asking of the ball just after the impact. Just after impact, right everyone? So just after impact momentum vector we need to calculate. Now obviously in order to calculate momentum vector you need to calculate velocity vector. So because mass is given, directly we will multiply the mass with the velocity vector, we will get the momentum vector. Now you should understand what will be the direction of motion of the mass just after the impact. If you are able to find out that thing, you will be easily solve this question. You will easily solve this question, right everyone? Okay, so now the mass is falling like this. What will be the direction of motion after impact? That is the main important thing. Now we'll focus on that thing here. Just a minute. Okay, now again I will draw the diagram here and you will see how the direction of motion will change. So this was the inclined plane. Okay, now I think inclined plane angle they have mentioned as 30 degree. Okay, here you should mention 30 degree. Now see, 30 degree they have mentioned. So right, see, the mass is falling like this. Okay, now if I have to calculate the velocity just before the impact, what will be the velocity? Root 2gh. Just root 2gh will be the velocity, right? So see, velocity of the ball, I will write here, velocity of ball just before impact. Just before impact, it will be equal to root 2gh. Okay, now it will be like 2 into 9.81, and what is the value of h? 4.9. Okay, you can easily calculate this one, right everyone? So this will be the velocity just before the impact. Now what is the direction after the impact? See, most of the students will say, okay sir, it will go like horizontally, it can go like this, but we should know at what angle it will go, in which direction it will go. So basically when I say direction, we are talking about the theta, okay, with respect to some any axis, right? So you should understand when the, see in the question, if you see what they have mentioned, collision is perfectly elastic. So when the perfect elastic collision is there, so at whatever angle it is approaching from this normal to the plane, let's suppose this is theta, so it will go like this with same angle theta from this reference axis, the axis that I have drawn normal to the plane. So if this angle is theta, this angle will be theta in the case of perfectly elastic collision. Now first you have to draw the line perpendicular to the plane. So here the plane is what? Inclined. So you need to draw the line perpendicular to the inclined plane, right? So that is what I am going to draw here. Okay, so this is the line perpendicular to the inclined plane. Now whatever this angle is there, same angle it will go, in the same angle it will go, right? See, now you should understand, if this is theta, you should understand this point. If this angle is theta, what is this angle? What is this angle? If this is theta, what is the remaining angle? Obviously, see, 60 degree it will be there. Okay, now this white line, that is inclined plane, and this red line is what? 90 degree. So this angle will be what? 30 degree. This angle will also be what? 30 degree. Now whatever this line, yellow line I have shown here, right? Okay, so I will mention like this. So this arrow, the dotted line with arrow shows the velocity vector, direction of the velocity of the ball just after the impact. Is this point clear or not? Right? So this is the velocity vector just after the impact. Just we need to calculate the, see, we need to calculate the magnitude as well as the direction. So direction they have mentioned in terms of I and j. So options are there in terms of I and j, right? We'll write those velocity vector here. Okay. So I will remove this part here. Now see. So I will draw this vector only. Now I will draw this vector. This is I direction. This is j direction. Okay. So velocity. Now this is the velocity just before the impact. After the impact, what will be the velocity? Okay. Just before the impact, it is there. Right. Now perfectly elastic collision basically means what? Coefficient of restitution will be what? 1 only. So coefficient of restitution is 1. Now let's suppose I am taking the mass as the first body, the inclined plane as the second body. If I apply this formula, so what will happen? See, now what I will write here, see everyone, here initially just before the impact velocity is what? V1, after the impact velocity is V1 dash. Okay, for the block initial velocity is V2 and final velocity is V2 dash, but we know the inclined plane is in rest condition, so both the velocities will be what? 0 only. Okay everyone, now see, right, so velocity, coefficient of restitution is velocity of separation, so it will be like this, V2 dash minus V1 dash divided by velocity of approach V1 minus V2, relative velocity of approach in the denominator, in the numerator relative velocity of separation. Is that point clear everyone? So V2 dash and V2 values are what? 0 only, right? Now is this we know that coefficient of restitution is 1. Okay, so I will write here, right, so this is 1 value. Okay, so this is value 1, V2 dash 0, this is minus V1 dash that we need to calculate, and here V1 value, see V1 value I am taking as negative according to the coordinate system, right? It is its direction is in the downward direction, direction is what? Downward, so negative value we have to take. Okay, that is what root 2 GH that we have calculated earlier also, minus 0. So again V1 dash value will be what? Nothing but root 2 GH. Okay, that you can easily calculate. Okay, this part you can easily calculate the value of root 2 GH, right everyone? Now see, so this value is nothing but root 2 GH. Okay, H value is 4.1 already given. So what is this angle? See, this angle is what? 60 degree. From the vertical it is 60 degree, right? So I will write this one. Okay, assuming this value. Okay, I am having the answers with me, so I am directly writing the answer here. You can just verify the answer also. 9.81 meter per second, approximately 9.81 meter per second I am having. So now I would write like this, this component will be 9.81 sine 60 and this component will be what? 9.81 cos 60. I hope this components are what? Clear everyone. So now how you will write the velocity vector? Now see everyone, velocity vector. Okay, velocity vector, how I am writing the velocity vector, please see. Velocity vector, see, this is the I component, 9.81 sine 60, okay, I cap plus 9.81 cos 60 j cap. So this is the velocity vector. Now you need to multiply the mass and you will get the momentum vector. Yes, clear everyone? Now see, we need to multiply the mass with the velocity vector. That is what we are having, 9.81 sine 60 I cap plus 9.81 cos 60 j cap. Okay. Right everyone? So see again, please check the values, 9.81 sine 60, 9.81 cos 60. Right, 9.81 sine 60, 9.81 cos 60, right? This is the values. Just see, obviously in the question they have mentioned the value of mass, yes, 2 kg. So just you need to multiply 2, in place of writing mass, I will just write the 2 kg, okay? 2 kg, okay. Now after putting all those values, approximately 17 you will get here. 17 I cap plus, and approximately you will have this 9.8 J cap, right? So just please check everyone and tell me approximately this is the answer you will get, right? Please verify the answer also, because this data is provided by you only, guys. And see, based on that I have calculated the answer. Okay, you can just verify the options, right? Whatever options is given, based on that you can verify the answer. So mass we need to multiply with the velocity vector. After that we'll get the momentum vector. Okay, I hope this point is clear. Now next question, a very beautiful question they have asked from this isentropic flow, or I would say like directly from the compressible flow. Okay, like nozzle and diffuser type of question they have asked. If velocity will increase or decrease after passing through a certain passage, pressure will increase or decrease after passing through certain passage. A beautiful question they have asked. And see, I guarantee you, if you know the basics now, directly you will get the answer. Okay, so just you need to follow some relation, you need to put the values in the relation, and you can after that conclude, okay, this will be the effect, so answer will be this one, right? Like that it will be there. So next question. Okay, now in the next question, see, please everyone, this is they have given. Okay, so let's suppose this is section 1.1, this is section 2.2. Okay, now at the inlet, see, at the inlet they have given pressure P1 100 kilopascal, right? Density 1 they have given at the inlet, actually 1.2 kg per meter cube, right? Velocity V1 they have given 400 meter per second, right everyone? Pressure, density, velocity they have given. Okay, yes or no? These are the data they have given. Now they have also given that area of section 2 is twice of area 1, twice of the area of section 1. Now they are asking actually in the options U1 is greater than U2 or U2 will be less than U1, like that they have mentioned. And they are also asking pressure will be what, less or more at the section 2.2, that is outlet. So that we need to check. Okay, but before that, first of all you need to understand what kind of flow is there at the inlet of this particular passage. I cannot say it is a diffuser, I cannot say it is a nozzle. We need to check the value of Mach number at the inlet. Is this point clear or not? Okay, just by observing this diagram, many students will say, okay sir, it is a diffuser only. Okay, it is a kind of diffuser only from fluid mechanics concept. But actually it is not a diffuser here in this case. That is what the trap they have framed for you. Okay, you need to identify such kind of traps, right? Because see, who will fall in the traps? Whose basic concepts are not strong. If your basics is clear, you will not fall in the traps, right? So remember this point. So these are the data. First of all, I will calculate the Mach number at the inlet. So that will be what? Velocity divided by C. So velocity of flow they have already given. Okay, 400 meter per second. That is what the value, 400 or 300 you need to check. Okay, and velocity. Okay, velocity they have given 400, right? Whatever the value they have given. Based on that I am writing. Okay, from you guys, one of the students have given this question. So see, velocity of flow. Okay, velocity of flow we have written. Now velocity of C, point C, velocity we need to calculate. That will be nothing but gamma RT. Direct formula you need to apply, right? I hope everyone knows this formula, gamma RT. For calculating the C value, we'll use gamma RT. Now gamma 1.4, okay, R value we know, but what is the temperature? See, for that the data is given for the inlet. So P by rho equals to RT only. That is for the location 1. So from this you can easily calculate the value of temperature T1. Temperature T1 you can easily calculate here, and you will get the Mach number also. Now if you calculate the Mach number here, you will be getting the value greater than 1. Okay, that I have calculated. You can also put the values and check whether Mach number is greater than 1 or not at the inlet, right? Now that is the point you get. After that you need to check one relation. After that you need to check one relation, and from that relation only you will get to know whether the velocity will increase or decrease, right? Right everyone? Now see, I will add one more page here. Okay, so you need to understand this relation. I hope many students have discussed, okay, in the classes we have discussed lot of time this relation also. This direct relation you should remember always, okay? This direct relation you should remember. Now, see, change in area, obviously, what is the change in area in this case? What is the change in area? Positive, because the area is increasing at the end. So, if you take the change in area, that is A2 minus A1, it is what? Positive only. Now, if you calculate the Mach number, it is coming out to be greater than 1. It is coming out to be greater than 1. Now, if you put the value here, see, obviously dA is what? Positive we are having. Mach number is greater than 1 that we have calculated. So, from this one, from this much information, can you tell me what will happen to dV? What will happen to dV? Tell me guys, what will happen to dV? Arey, velocity dV, change in velocity will be also positive. So, change in velocity is positive, basically means velocity at the outlet, it increases. dV will also be positive. From this analysis, I can say dV, change in velocity is what? Positive. So, it means what? Velocity at the outlet is greater than inlet. And obviously, pressure P1 will be what? Less than as compared to P2. Right. So, this will be the answer here. Now, you should understand this point also. It is acting as a, see, when Mach number is greater than 1, supersonic, and as the velocity is increasing, so supersonic nozzle it is there. See, when I say nozzle, no, it means velocity will increase. So, but before calling it as a nozzle or diffuser, we should understand whether velocity is increasing or decreasing. Are you getting my point? So, first we have decided the velocity is increasing, so that's why we are calling it as a nozzle. Otherwise, if someone without understanding the data, they will directly say it is acting as a diffuser. From the given diagram also, they will say this is kind of diffuser only. But in reality, it is not a diffuser. Supersonic nozzle case, it is this. Right, everyone, please tell me, is the answer is clear, yes or no? Okay, is the answer is clear, yes or no, everyone? Okay, answer is clear, yes or no? Okay. So, we'll write here completely. Right. So, this relation is what? Very, very important. Focus on this relation. Okay, very important relation. So, we have calculated Mach number at the inlet, which is coming out to be greater than 1, approximately 1.17 it is coming. Temperature T1 you can calculate from the given data at the inlet section. Right. After that, we have utilized this relation. We know that change in area is what? Positive. Mach number is greater than 1, that we have calculated. So, dV will be what? Positive. So, finally, if you see the options, right guys, I am writing the answer here. So, U2 is greater than U1 and P1 will be greater than P2. Right. So, this will be the answer guys. P1 will be greater than P2 will be the answer and U2 greater than U1. This will be the answer, yes. Okay everyone. So, this was the very interesting question. I know most of the students have done the mistake just by directly saying it is a diffuser. They have told that velocity at the outlet will be what? Less than velocity at the inlet. So, that is what, see, in the gate examination actually they are checking your aptitude only. They are checking your aptitude. See, it seems to be a diffuser, but actually it is not a diffuser. So, that is what the trap they have framed in this question. Okay. So, I hope this solution is clear to everybody. And see, we have tried our level best to solve all the possible questions that you have given to us as a memory based questions. So, whatever data you have provided, based on that only we have solved the question, right? So, thank you so much from your side also for your support that you have shown to us, and whatever, see, solutions we have provided, it's because of you only, guys. Okay, thank you so much everyone, and see, the solution and a complete PDF will be there in the description box also, and we'll post that PDF in the community section also. Okay, you can download that PDF also, right everyone? So, thank you so much everyone guys, thank you so much. And one more information is there guys, there is one zero fee program is there. Okay, you can access the entire course of zero fee program. Directly you can access some free courses, some free video lectures are provided in that particular program. You can see and you can enjoy the sessions of the zero fee program also. Right everyone, thank you so much.